Moving from a simple AutoCAD drawing to an intelligent GIS is easier than you think. Geographic Information Systems, or GISs, are not just big systems that live outside of AutoCAD. Now that AutoCAD is on subscription, the AutoCAD Map 3D toolset is a free component. So if you own AutoCAD, you have a GIS. In my LinkedIn Learning course, I dive into toolsets that will bring the power of GIS to life, and we can make AutoCAD move way beyond the plain old DWG. So join me, Gordon Luckett, in my course, AutoCAD Map 3D Essential Training. Let's take a look at object data tables. They're used to store your own custom properties. Every feature in your DWG can have an object data attached, and this starts with the creation of an empty place to put this data, the object data table itself. So let's create an empty one now. Inside a brand new DWG, I'm going to go to Map Setup ribbon and click the Define Object Data. Once I'm inside here, I can click a brand new table, and I'm going to call this table Streets, because this table will contain data that I'm going to eventually attach to different street segments that I draw inside of AutoCAD Map. They could be P-lines or just lines or so on. So I'm going to call the table Streets, and then I'm going to choose the first column. The first column, I'm going to call it Feet ID or Feature ID. The Feature ID is a unique number that I'm going to assign each segment of road. So it can be an integer, so 1, 2, 3, 4, a character, anything you could type on your keyboard, a point, which is X, Y, and a real, which is basically a decimal number. So 88.3, for example, is a real. Feature IDs are typically integers, so we're going to pick on integer, and we'll just say unique ID for street. And the default I'm going to set to 0. If anyone attaches this table to an object, it'll automatically just populate with a 0, so you'll know to change it later on. So I'll click Add. So now we have an empty table called Streets with one column in it, Feature ID, and it's an integer. Now to add another feature, all I have to do is type over the word Feet ID, and this time I'm just going to call it Street. It'll be the street name. So it's not going to be an integer because that's a number. I want it to be a character, so you can type anything you want. So I pick character, and we'll just say this is the street name. And I'm going to leave the default blank. So this is a street, it's a character, the description is street name, there's no default value for the street names, and I click Add, and you'll see that I now have a table called Streets with two object data fields, Feet ID and Street. Let's click OK and close. So now you can't see it inside the drawing. There's nowhere that shows you that there's some empty object data sitting around. You actually have to go back into Map Setup, click on Define Object Data to see it listed there. Now, once it's there, we can use it to attach to data. Now, I don't have any data in this empty drawing, but if I did, I can use this table and actually populate it. Or if I don't want this table anymore, I can hit Delete. Or if I want to add more columns to it, I can click Modify and just type in a different column name here and click Add. But either way, I've created an empty table that now can be used to attach object data to any feature inside of AutoCAD. You've learned to create this empty object data table that will eventually contain all your attribute data that can attach to AutoCAD features. Object data can be part of any feature in your DWG when using AutoCAD Map 3D. With an empty object data table, you can add custom information to all your graphics in the DWG. What we're going to do now is draw a brand new line and then attach object data to it. This line will be a new street. So the first thing we're going to do is we're going to pick on View and go to the Name Views. There's a name view called Suffolk Street West. Let's pick on that. And it will zoom into a section of the city where there's a street segment missing. So we're going to draw a brand new line between the two green circles. So I'm just going to type on the command line, line, and press enter. And the first part of the segment will be at the bottom of the screen. We're going to snap it to the center of that circle, and then we're going to snap it to the center of the upper right circle where it says endpoint. And there's the new segment. I'll just press enter to finish. So now we have an empty line right in the middle of our DWG. Now I want to attach object data to that simple P line. So all we have to do is click on create. In the create ribbon, you'll see the attach detach object data. Now there's a pre-existing table in here called streets. It has two columns, unique ID for streets and street name itself. So for the unique ID, I'm going to pick on it. You'll see feature ID. I'm going to give it a value of 4,000. And to make it stick, I always press enter. There, it's stuck. Now for the street name, I'm going to call it Suffolk space street and capital W. It's a west. Again, I'm going to press enter. And now it's stuck. And the reason I press enter is so that the value gets attached. So you can see that the feature ID is now 4,000. It shows you what value to attach. And street name is Suffolk Street West. Now, this isn't attached to anything yet. I have to physically attach it. So underneath where it says attach to objects or detach from objects, I can click on attach to objects. The good thing about this is it'll overwrite any existing object data that's already on there, or you can detach it from the object if you don't want it any longer. So in this case, I do. So I'm going to leave the overwrite checked and I'm going to click attach to objects. I'm going to pick on that brand new line we just drew and then press enter. It's now attached. How do we know? If I pick on that one line and I right click and choose properties, I'll expand my properties pane so you can see that a little better. And I scroll down to the bottom. In my properties, there's a group set called streets. You'll see OD:streets. That stands for object data streets. So now I've got custom properties in here. I've got a feature ID and a street. So I can pick on anything. Now there's already some existing data in here. So I'm just going to hit escape and pick on another line segment. And I scroll down. Aha! There's already a feature ID and a street name attached to another segment. So I'll hit escape. And we can save this drawing when we're done. Now, the nice thing about this is for those who've used AutoCAD in the past, you can see how powerful the use of object data can be, because you now have an ability to add custom properties to any feature inside of AutoCAD. You can't do this in the regular flavor of AutoCAD. You can only do it in AutoCAD Map or those that are built on top of AutoCAD Map, such as Civil 3D. So we now have the ability to attach your own data to any feature inside of AutoCAD. Pre-existing object data enriches your DWG and enables you to get much more out of your drawing. But editing that data takes this enrichment to the next level. Let's take a look at two completely different ways to edit the object data in your drawing. First, we're going to use the classic object data tool. It's called Edit Object Data. It's under Tools ribbon, and there's a button in there called Edit Object Data. The command is ADE, Edit Data. So let's do that. And we'll pick on the long segment of road on the eastern side of the drawing, right there. And you'll see that the unique ID is 1325 and the street name is Stone Road East. So I'm going to highlight street name and I'm going to change this to EAST and click OK. And now I've modified the object data of that one line segment. Now if I pick on it again and then pick on AD Edit Data, then select the line, you'll see that the street name is Stone Road East. Let's change this to Stone Road E and click OK. Now I've corrected it. So using that ADE edit data and the command line, I was able to connect to that. So I can actually type that again, ADE edit data, and allows me to pick on it again. There we go. See, that's the same as if I went to Tools and found the map edit. And some of you may prefer typing ADE edit data rather than clicking on the Tools ribbon and finding the button up in the corner. Now there's other ways to edit data. That's the classic object data way, the ADE edit data. The other way is just using AutoCAD properties. So let's look at that. So if we go on the View ribbon and we go to the named view called Suffolk Street West, we'll pick on that. And right in the middle of the screen, there's a line. So if we pick on that one line right in the middle, and we right click on it and choose Properties, in the Properties pane, we'll scroll to the bottom and you'll see Object Data. So what I'm going to do is I'm going to change the street name from Suffolk Street West to Suffolk Street W. And I'll just change it and press enter. It's now saved. So if I close the dialog box and I hit escape twice, let's pick on that again, right click and go Properties. And if you scroll down to the object data, sure enough, you'll see Suffolk Street West has been updated. So you've seen two completely different ways of editing. There's the Properties pane, which I prefer personally because it's so easy to edit any sort of data, or you can use Tools and pick on the ADE Edit Data to adjust that same Suffolk Street West. So you have two completely different ways. So object data gives you the ability to share attributes with anyone who uses the file. This enriches your DWG with object data, opens the door for all sorts of advanced queries as well as data sharing and distribution. And this object data is found within the DWGs created by AutoCAD Map toolset. Remember, AutoCAD Map is a toolset, so it's on top of AutoCAD. So you can find object data in the AutoCAD Map toolset, or if you use Civil 3D, AutoCAD Civil 3D, object data also exists in there. So you could share these modified DWGs with both AutoCAD Map and Civil 3D. Connecting to databases is an extremely powerful way to get information into your drawing that you or your department does not even maintain. For example, you may want to attach billing information to your drawing directly from accounts receivables to each customer point in the map. Well, let's look at attaching a database now. First, we're going to switch our map to Map Explorer in the task pane. The reason we do that is because we're going to be attaching our database to data sources. That's a folder inside of Map Explorer. Now, if you don't see the task pane at all, just go to View, and you can toggle the task pane using the Map task pane off and on like that. It'll turn it off and turn it on again. If you don't see View task pane, you can also use the command line. It's Map W space. And you just type that, and that'll allow you to turn it on or off. You can say on or off like that. And I'll just repeat that command and get it back again. So right click, repeat Map W space, and I'll say on, and it's back. And what I really want is the Map Explorer, because again, I've got this data sources folder that I'll be working with, and we're not going to be using the drawing or the query library, anything like that. We're just going to be using data sources. And we're going to drag and drop in an access file. But before we do that, we have to make sure we either have Access already installed, or we install the Access runtime. Now, the Access runtime is actually free from Microsoft. So if you Google Microsoft 365 Access Runtime, you'll find this at the Microsoft site where you can download and install the Microsoft 365 Access Runtime. This is free. And you can download the 64-bit download in this case, and I downloaded it. And if I hadn't done this on this computer that I'm using today, I would not be able to drag and drop an Access database in. So I've already done that. So now what I can do is I can go back to AutoCAD Map, make sure I'm in the task pane and Map Explorer, and I'll just open up the folder where the Access file is. This is an older Access file. You can tell because it's got the extension MDB. The newer ones have the AC extension. So let's just drag and drop zoning MDB into the gray area of my Map Explorer. It doesn't have to be right on the data sources folder. It could be anywhere in the gray area. I'm going to let go. And what will happen is that Access file will be now connected to this particular DWG. This is a blank DWG, but now I've got an Access file connected. This Access file is very simple. There's no queries in it. There's only one single table. That's zoning with a big Z or big Z right here. And if I double click on zoning, you'll see it'll open up the table inside of AutoCAD Map. I can now see all the data in Microsoft Access. Even though I really don't have a full version of Access running, I can actually use AutoCAD Map to look at data sets. This will react the same whether I'm connecting to Oracle or SQL Server and so on. You don't drag and drop SQL Server or Oracle because they're enterprise databases, but Access files you can. So you'll have to manually create the connections for those. And you just have to do that by right-clicking on data sources and configuring a data source. But in this case, we're just dragging and dropping the access file directly in. Let's go back into the data view zoning table. And of course, I can double click on any of these columns and reorganize. For example, I just sorted parcel ID up and down, or I could double click on zoning and start from the highest to the lowest, one zoning all the way to A, B, all the way up. I can filter this data too. Now there's a button here on the end called SQL filter. So say I only want the residential zoning. So I can click the SQL filter and it'll give me a dialog box that allows me to filter just residential. So let's try that now. I'm in the table filter. It's already going to build SQL language for me. Select star from zoning. That's what's happening. And the column I'm filtering is, there's only 3 columns, ID, parcel, and ID. So the one that I want is zoning. And I'll say the operator is like. I have all these ones, equal, greater than, less than, and so on. But what I want is one that's like a particular value. In this case, I want it to start with a capital R. And to say a wildcard or anything else that I want, I just have to put a % sign. So now I have zoning like R % sign. That means anything that begins with a capital R is fair game. So I'll click add. So now it'll say any zoning that has an R at the beginning, let's look at it. So if I click OK right now, my data view zoning only shows those zoning values with a capital R at the beginning. Now, if I scroll all the way to the bottom, you'll see I've got a few false positives. I want residential, but I have road and railroad. So let's filter out those two. Let's go back into the SQL filter. Oh, there's another filter right beside it called spatial filter, but we can't use this yet because this data is not connected to any graphics on the screen. In fact, this is a blank map, so there's no connectivity. We'll learn that in another lesson, but we're going to stick with the SQL filter right now. So let's filter out just the roads. Here we are. So to filter out the roads, meaning I don't want to see any of the roads, I'm going to say, and the zoning equals, now I can hit this ... What this will do is it'll get every last zoning value, unique value from the database. And this may take a while. There's about 35,000 records in my database. It's going to take a while. Now, if I had 1 million records, this would take a very long time. So be careful with the ... But in this case, I'm going to scroll down to the word road. I could have typed it in, but I just wanted to pick it. There we are. So I'll say zoning equals road. Oh, I don't want that. I actually say where it's not equal to road, and I'll click add. So now it's to get everything that begins with R and where zoning does not equal road. Let's hit OK. And it should filter out all the roads. It does. So let's scroll to the bottom, see if we missed anything else. Aha, there's a couple railroads. There's RR space 1 and RR dash 1. Well, I just want to get anything that begins with RR and get that out of it. Let's go back into the SQL filter and do one last filter on this particular data set. So let's say, and zoning is like railroad, so RR, and I'll put a % sign so we catch all the different things with RR at the beginning. Oh, and I want it not equal to that. So I'll hit add. So now I'll get everything that begins with R, but not equal to road and not like RR railroad. So this should get every type of zoning as long as it's not road or RR. Let's hit OK. And now it's even filtered further down. So I scroll to the end, you'll see the roads and RRs are gone. I've got just a pure zoning residential in my filter. Now I can just reset this. I can go back into my filter and clear the whole thing. So we'll do that. Or I can delete an individual value like this, or I can clear all and just wipe the entire filter altogether. I'll hit OK. And now I'm back to all 35,000 records. And of course, I can always edit this data. So for example, at the very end, there's a WL. I could say WLL. And you see the pencil beside that particular record. It means I'm editing it, but when I pick somewhere else, you can see the pencil disappears, and that means it's been written back to the database. and I'll go back in and I'll fix that, put a WL, just, and the pencil's there again, and I pick somewhere else. The pencil goes away, it means it's now committed back to the database. Now, this only works if you've got rights to edit that data. So for example, if I connected to some big SQL Server database and my username only had read only, I'd get a little error here saying I can't edit that data. I can only look at it. And that's fine too. So depending on your user rights, you can connect to any database you want and be able to filter and look at it. You could even export it if you wish. But the bottom line is we have the ability to view and sort and filter data from any database, and in this particular case, access. So now that you've seen how to attach the database, you might realize that you have other databases you wish to connect to at your organization. And now you can. So depending on your username and password, you may also be able to edit that data too. Binding records from an external database to each of your objects in AutoCAD is an effective way to keep your data up to date. Creating a bridge between the database and AutoCAD and then maintain those links is a really important practice. First, let's open up the parcels DWG. It's basically a series of closed P lines that represent the parcels of our city. Then I'm going to drag and drop the zoning data MDB. That's a Microsoft Access database into the Map Explorer tab. Make sure that's open. So I'll drag the zoning data into the gray area of the task pane, and it should automatically attach that access file. There's only one table in this access file called zoning. And what I want to do is I want to connect this zoning database. So if I double click on it, you can see it in the data view. I'm going to use the parcel IDs. These are just unique numbers. They're integers. Every single parcel has its own unique ID, and I want to use that to join to the parcels on my map. Now, if I zoom into my map and look around, you can see that there's a series of P lines or closed polylines. I'll have a quick look at that. Let's open up my properties pane. I right-clicked, chose properties, and open up my properties pane. You can see, yes, they are closed polylines. Okay. But inside of each closed polyline, I'll hit escape twice and then zoom in. There's a 1, 2, 3, 5, 4. Now 1, 2, 3, 5, 4, that one right there, that is the parcel ID in our database. So what our goal is to connect each of these parcels, closed P line, that's a closed P line, that's a closed P line, and so on. I want to connect every one of these or some of these into our database. Now to do that, we've got to tell the database what column to use as the link. So we create a link template. So I'm going to right click over link templates in my Map Explorer and say define link template. We're going to connect to the data source called zoning data. That's the access file. There's a table inside that called zoning. And a link template is just basically a way to tell AutoCAD what column we're going to be using to connect to the graphics on the screen. Now, I usually like to name my link templates something very descriptive. So I'll put in the name of the table, zoning, and I'll use an underscore. And the column I'm going to be linking to is called parcel ID. So I'm going to put that in. And then I'll just call it LT so you know it's a link template. And the column I'm going to be connecting to is the parcel ID. So all I'm doing is creating a link template. So nothing's happened yet. Nothing's linked to the map yet. I'll click OK. And this is a template that I can use to join the graphics on the screen to the database. So the data sources contain access data in this case, but it could be any kind of data. It could be Oracle, SQL Server, whatever you want. But the link template is the prototype that allows me to say, use this column to tie these objects to the screen. Well, how would I do that? Well, let's zoom into another parcel. So I'm going to zoom out. I'm going to take the one right here, the parcel at the very bottom of the map here. And I'm going to zoom in and look at this number. It's 12452. Okay, I'm going to connect that parcel right here, 12452, to the database. So the first thing I'm going to do is I'm going to open up the link template. Now it looks exactly like the data view if I double clicked on zoning. The only difference is I've got a link template listed here under link template. That means I'm all set up. So what was the number that we chose? I'm going to zoom in and look at that. 12452. Okay, let's go back to the data view and let's just do a quick SQL filter where the parcel ID is 12452. Hit add and hit OK. And there it is. There's the parcel 12452. I've filtered it. It's the only record. Now, if I want to connect 12452 to that property, all I have to do is highlight the record inside the data view, right click, and choose link to object. Now I can only do this if there's a link template set up, because what it's going to do when I link to object, it's going to take that 12452 and attach it to the line I'm selecting. I'll show you that right now. Right click, link to object, pick on that one parcel on the edge and press enter. It says one record linked with one object. To prove this, if I pick highlight, auto zoom, and auto select, those three things will highlight, zoom, and select the feature that's in the link template. Now watch when I pick on that again. Sure enough, it highlights it, zooms, all sorts of things. So I'll hit escape a couple times here just to clear it. Go back in. Now let's clear that SQL filter. I'll go clear all and hit OK. Now there's all the data. So let's do another one manually. So let's zoom into the next parcel. It's 18051. So let's go back in here. Now I could just sort by parcel ID and scroll down to find 18051. So again, I'm scrolling through, or I could do that filter just like that. Let's scroll down a bit more. You can see that would be quite time consuming. So let's use the SQL where parcel ID equals 18051. Make sure it's in there. Oh, I didn't hit enter. Again, parcel ID is 18051 and I have to hit add. Ah, there we go, add. Now I click OK and there's 18051. Remember, that's the one we want to choose right here, 18051. So I right click on that, link to object, choose the second one. And there you go. And if I pick on it, you'll see it's highlighted, it's connected. Those two features are connected. Another way to look at that is all I have to do is pick on one of these parcels, right click and hit properties. And if I scroll down, you will see that there's an LT type as opposed to any other type. If it was object data, it'd be OD, but this is LT. And there's the name of it, zoning parcel LT. And you'll see there's a little key next to the parcel ID. That's the primary key. Parcel ID is what it's linked to. That's why there are little key symbols there. And there, right inside of my properties pane, is the value. And I can actually go in here and update. If I have rights, I can change the zoning. I can change the parcel ID. I could change the ID. But mainly, I'd probably change the zoning in this case. And if I modify this, say I put in B and press enter, I've just updated the database. Let's put it back to A. There we go. And now we've updated the database. So we've got a full connection between the database called zoning and my graphics on the screen. Now that would take a long time if I was going to do that manually for every single parcel in my entire city. So let's look at a better way to link these closed P lines to that same database. Now we're lucky because inside of every single parcel, there's a piece of text with a parcel ID in it. So we don't have to guess what each one is. So I can right click on the link template and use another tool called generate links. There's 4 ways to generate links. So I can generate the database that goes directly to a block. And if you use a block, it has to have a block attribute in it that matches the column in the database. So in this case, if I were to link to a block, it better have a block attribute that matches the parcel ID, for example. Now, that would link directly to the block itself. It wouldn't link to, say, the polygon or anything like that. Now, with the text, I can link the database directly to a piece of text. So you pick on the piece of text, it opens up the database, and you'll find out what's inside of it. But that still is just a point, just a piece of text. It's not any kind of polygon or anything like that. So I usually consider the blocks and text as a direct link to the database on the screen. So kind of like a point. Now, enclosed block means there's a block with an attribute that matches the column in the link template. So say I have a block that's called parcel ID and there's a block attribute inside with the number of it. I can link to a polygon. So if this enclosed block falls, the key word here is enclosed. Enclosed means you're inside of a closed P line. So always remember that. So it says enclosed, that means it has to fall inside of a closed P line because AutoCAD Map considers those closed P lines as polygons. The other one, and the one that we're going to use, is called enclosed text. That means the text is inside of a closed polygon. Now we're going to create a database link using the only link template in my drawing, zoning parcel. I could create object data. It could take the text inside of each of these polylines and push it out into object data and create a link to it. So I could do that too. And sometimes there are options to do that, or you want to do that. But in our case, we're sticking with creating a database link from the link template called zoning parcel ID that will connect based on the enclosed piece of text. So if I do this, it will actually create links. Now I can change my data validation. I could say do some data validation, or links must exist or don't bother, or create a brand new record using that piece of text inside of each polygon and insert it into a database. That's actually quite powerful to do if you don't have anything in your table and you just want to populate it with the text on the screen. That's a very powerful way. But guess what? We already have data in the zoning table with parcel ID, so I don't need to do that. I'll leave none. Okay, let's click OK. And I'm going to pick a few of these parcels in this one subdivision. So it's going to ask me whether I should select or all. Now, if I do all, it should take about a half an hour. So I'm not going to do that. I'm going to actually type select and hit enter, or S, enter. And then I'm just going to select a few objects. And I'll just basically pick a few in this one subdivision. Those ones there. And maybe I'll pick a few more in there. There we go. Make sure I've got everything. Okay, so I've got about 26, and I'll just press enter. So I don't want that many. I just want this little subdivision right here. And it did run, and you could see if I scroll up, it did 27 links. Very good. So if you want to see if it did work, you just pick on one of the parcels, and you could right click and go properties, and you can scroll to the bottom and see if there's a link template attached to that one property. And yes, it's connected to parcel ID 3799. And the reason that closed P line worked is because inside it, someone happened to draw a piece of text right here with 3799 inside of it. That's why it works so well. Another way to do it is to double click on zoning parcel ID, go to highlight, and highlight records by selecting them on the screen. So I could just select a whole bunch of objects like this and press enter, and it'll highlight those records in the list in yellow. Now I could just show only highlight records like that, and there's the ones I selected. So I selected the 26 that link, and I just have to pick on each one to show which ones link back to the database. So just 26 of them are linked in my database. So now you can see that all these parcels are automatically linked because they're closed P lines. And that's a very powerful way to edit that data or view that data. Again, I can go in and change the zoning if I wish to, if you have rights. Now, because this is a Microsoft Access file and there's no passwords on it, I'm able to edit the data live. Now, if you're using something like SQL Server or Oracle, your user will have to have rights if you want to be editing any of this data. Otherwise, it's read-only. Okay, so you can see that link templates tell AutoCAD Map what database, table, and column to use in order to tie the objects to the individual pieces of data. Once a link template is created, you can then manually or automatically generate links between the database and the graphics. Now remember, because it uses text or blocks, or enclosed text or blocks, the automatic tool is only for like points, text and blocks, or polygons, closed P lines. So if you've got a lot of roads, linear features like roads or anything like that, or pipe, there's no automatic generation or generate links for those features. You're going to have to do the manual way where you right click on an object and say link to object. And there's no way around that right now inside of AutoCAD Map. Source drawings are those DWGs that contain all your information. Attaching source drawings to another, often blank drawing, enables you to combine all that data and query information from multiple data sources. The nice thing about that is that it does not lock the drawing. So potentially you could have thousands of people connected to the same source DWG. Let's learn how to attach source drawings to our current project. I've opened up the guelph.dwg. Next, I'm going to go to the Map Explorer, pick on Drawings, right-click, and click Attach. Now currently, it only attaches to the C drive. That's my only alias. So I'm going to create a brand new alias at the top, clicking the button called Create Edit Aliases. The only one right now is the C drive, but this one I want to call exercise files with an underscore. Exercise files like that. And I'm going to browse to my desktop. So I'll browse to see Gordon Luckett. That's my username. Desktop, and choose exercise files and click OK. So you can see that my actual path is C users Gordon Luckett desktop exercise files. Now obviously it's not going to be your name, it's going to be whatever you're logged into your desktop with, where you extracted your exercise files. Click Add. The nice thing about using an alias to point to all your drawings is that if you were to give this project, so source drawings plus the DWG that has everything attached, it's going to point to an alias called exercise files. They may be located somewhere else. So you can always go in and modify the actual path to make sure that your source drawings don't break when you open them up. And that's a very handy thing. Whereas if you linked it directly to the C drive, that doesn't change. You'd have to manually change what your C is. So by adding a drive alias called exercise files, you could put that folder of exercise files anywhere you wish and just change the alias to them. So this is a very powerful tool, the idea of an alias or drive alias. Now let's switch to the drive alias, exercise files, and you can see the various chapters. Now we're on chapter 3, so go to chapter 3, 0301, and we're going to attach 3 drawings. The buildings, I'll click Add, the hydrology, Add, and the streets, Add. Now, Guelph is currently open, so it's not even selectable. And you'll see once you've attached the drawings down below, they're no longer selectable. So you can see that now I've got drawings, exercise files / CH03, buildings, exercise files, again, hydrology, and exercise files, streets. I've attached 3 different DWGs. I'll click OK. Now they show up in my task pane. Now I'll make my task pane a little bit bigger so you can read it. There we are. So you can see exercise files, buildings, hydrology, and streets. Now we can quickly view these all by right-clicking on drawings and do a quick view. And it'll zoom to the extents of the selected drawings. All 3 are highlighted. I'll click OK. And there you have it. There's what the 3 different drawings will preview. We've got hydrology, we have buildings, and we have streets. As I zoom in, you can see. Now all this data is coming from 3 completely different drawings. Now this is very similar to an external reference or XREF that's often used inside of AutoCAD. The difference is that we now have an ability to connect multiple drawings to one file and not lock those files. So if anyone else uses AutoCAD Map, they too can attach the buildings, hydrology, and streets without it being locked out. So that means you can have thousands of users connecting to this. Now, a quick view is just a preview of what's inside the drawing. So I could simply regen, RE, at the command line, and click enter, and everything disappears. Now I can obviously right click on each individual object. So say I just want to preview the buildings, I could right click and go a quick view of just the buildings and they show up. Well, let's zoom in a little bit more, and I'll right click and look at the streets. Right click, quick view, and the streets show up. Now I can also right click on hydrology and go zoom extents. And it'll zoom to the extents of the drawing, even though it's not even quick viewed yet. Now I'll right click and go quick view. And we have it. So now I've got an attachment in this drawing, this guelph.dwg, to 3 of the source drawings. Now normally source drawings are drawings that have the data inside. Somebody's put a lot of work in. They may have an object data attached to it. It may have linked template data. It's definitely been cleaned up. This is a source drawing. And normally what you can see is in this Guelph drawing, so this is the project drawing, has attachments to all these source drawings. I normally don't draw inside of the project drawing unless I'm going to be saving back to the original. We'll get into saving back in another lesson. But the idea is this, that your data is stored in individual drawings, and then you've got this one global drawing that points to all those source drawings. So sometimes I'll refer to it as a project drawing or main drawing, and that links to all these source drawings, and that's what these are, source. They're the source of our data. So attaching source drawings to your map does not mean the data is available to you actually query it in. Now we haven't got to query yet, but remember that it's not actually in the drawing. I can't actually pick on anything per se. If I highlight, it's not available. It's just there. It's sort of a quick view. And if I regen, it always disappears just like that. So using that quick view, you can quickly see what kind of data is available in the attached source drawings. So later on, when we use the query library, we can know what to pull in and where we can pull it in from. Querying source drawings using location enables you to choose or draw a boundary which will cookie cut your data from all your attached drawings. For example, you can query only the drawings information that falls within a neighborhood, even though the source drawings may cover the whole city or region. So first of all, let's attach the drawings that we want to query. So right click on drawings and click attach. We're going to use our exercise files alias, which points to our exercise files on our desktop. Then I'm going to go into chapter 3, lesson 2, and we're going to attach the hydrology and streets drawings to our current drawing, which is guelph.dwg. So we have hydrology and streets and chapter 3, exercise 2. Okay. So now that we have that, where is everything? So what I like to do is really quickly do a quick view to give me an idea of what's in my drawing and zoom to the extent. So there's a quick view. Now I know what's in these drawings. They're not actually in the drawing yet. I just have a preview of what's inside. And this is a handy tool. So it centers my map to where things are, gives me an idea of what's inside each of the drawing. So I actually could do a query. Now to do a proper query, I can go into the current query. And I have a dialog box where I can do all sorts of different queries. The one type is location, but we have 4 different types of queries here. We've got location, basically geographic location on the map, a property, and those properties range from all sorts of things such as layer or group they're in or text value. The data, I'll quickly click on data. This is the object data or database links or attributes of the block. And SQL is if you've got a link template connected, you can query the data through the link template. But we're going to focus on location only in this particular exercise. So let's pick on location. And here are the location types. We can say bring in everything. So basically it's like just give me everything. Don't limit anything. Create a buffer fence. So basically draw a fence and it'll buffer it slightly. Draw a circle or a fence, a single point, a polygon, or a polyline, or just make a window. Now I'm just going to make a simple window and define it on the screen. So I'll just make a simple window here to here. And I'm going to leave the query mode in preview. Now the query mode in preview is interesting because it's just like a quick view. So you can consider preview query mode as a quick view. You know, when we right click on the drawing, on the list of drawings, and we do quick view, that's like a preview. But what's nice about this is that we could create all sorts of complex queries about our data and just see if it'll work by hitting the preview mode. When we're complete, we hit execute query. If you click OK at this point, nothing happens, but it remembers what you did in this dialog box. So execute query is a lot different than OK. OK just means remember what we just did. So if I hit OK right now, nothing happens. I'm going to go back into the current query and you'll see, it still has location crossing window that I drew before, and it still says preview mode, but nothing happened. Nothing actually happens until you hit the button execute query, which I'll do now. Let's click execute query. And what it did is drew a window, and anything that fell within or crossed that boundary from these 2 drawings are now there inside our map. Now, if I try to pick on something, it picks on everything because it's just a preview mode. So if I do regen or RE, it disappears. So let's just do a quick view again to get everything back. Quick view. Okay. And let's go back into our current query. We'll double click and we'll clear that query. Let's try a different type of location. Maybe I'll do a circle. So I'll pick a circle and hit define. And right in the middle of my city, I'm going to draw a circle. That's about right. And then I'll say execute and see what that looks like. Oh, isn't that great? There's basically the downtown. Maybe I don't like that. So I can go back into the current query and I'll go into location and I'll say a circle, define, and I'll make a smaller one right here. That's more like it. There we go. Oh, but look what happened. Because I didn't clear the previous query, I have two. I have crossing circle and crossing circle. Let's just clear the query and try that again. So I'll go back into location, pick circle again, and define it again. Oh, no, I don't like that one. So clear it. Let's hit location, circle, define, and I'll click right in the middle. There we are. Now I'll hit execute. Now I like what's happening here. It's just bringing in the downtown. You see how it curves around the river? So I'm happy with this query. So let's go back in. Now instead of preview mode, I'm going to choose draw mode. And the difference is preview is a quick view. That means those objects aren't actually in this current project called Guelph. But when I hit draw, it'll actually bring out any objects, blocks, lines, P-lines, whatever's in the source drawings will actually be redrawn in my current project. So it's actually going to take a copy of the objects inside those source drawings and bring it into my current drawing. So let's execute that. Aha, it actually queried them in and I can actually pick on individual objects now. So if I pick on this road segment and look at its properties, you will see it's actually a line and it has object data attached, which can be edited. Now you have to be very careful at this point because even though I've got the data in my current project, this is queried in, there's still a connection to the live data back in the original file. So if I edit this in any way, whether it's the object data or I grab a grip and move it around, it's actually going to save back to the original DWG, even though it's attached to the current drawing. So what we're doing is through remote control called a save back, we can actually edit and create new data and put it back into the source data. Now this is a very powerful tool because what I just did is I queried a sub area of the current project. You could potentially have data for an entire country, but only query in a little area at a time to work on. So I could have a source drawing that is too big for my computer to open directly, but by using AutoCAD Map and querying location, I can query in a subset of that data, work on it, save it back, and then keep working on it and requery it. And that way I could have thousands of people working on the same DWG that covers a huge area, but only work on a subset of that data at any one time. That's the power of a location query. You can query source drawings, edit it, and save back. Now we haven't done any editing yet, but we'll do that in the future. So location queries are an effective tool for trimming out only the data you want in a particular area. Using draw mode rather than preview mode enables to edit that data and save it back to the original file. In this way, you could edit a drawing with data for a whole country, but only edit data at a city level with the location query. Often, when querying attached drawings, you only want objects that have a particular AutoCAD property, such as layer or color. The property query is perfect for that situation. For example, you may want to query all the drawing components for a layer called roads, even though the roads layer spans multiple drawings. Let's try that out. First, we'll open up the Guelph DWG. Then we're going to use the drawings attach under the Map Explorer. Make sure we're going to exercise files. If you don't already have this alias set up, I have an alias called exercise files that goes to C users, your name, desktop exercise files. That's where I extracted the exercise files. Now this is chapter 3, and we're going to go to 0303, and we're going to attach buildings, hydrology, and streets to our current drawing. So we'll have those three, buildings, hydrology, streets, and click OK. We'll right click on drawings and do a quick view, and we'll zoom to the extents of the current drawing. So this will give us an idea of what's in those three different drawings. We have buildings, hydrology, and streets. Let's zoom in. And you can see all the different layers. Now we double click on current query, and what we're going to use is the property query. We have location, that's for geographic location. We have property, those are AutoCAD properties. We have data, that's typically object data, and SQL, and that's linked template data. So let's go to the AutoCAD property dialog. So query type is property, and we have all these different types. We can pick a particular object type. So only give me closed P lines. For example, I could pick values, and there's all the different types that are in the source drawings, everything from a 3D face and so on. I can choose a particular block. So if there's any blocks in those drawings, there aren't any in that case, or color, and I could choose a particular color to query by, or anything like that. But the most powerful one that I find, and the one I use probably 90% of the time, is the AutoCAD layer, because I usually manage all my data based on the AutoCAD layers. So this way I can query a particular layer or multiple layers. Let's try that. So if I pick value, I could say bring in just the buildings. So even if there's buildings on multiple drawings, I could say if it's on a buildings layer, doesn't matter what drawing, query it in. So let's try that out. So I chose layer buildings. Okay. I'm going to leave in preview mode for now just to see what comes up, and I'll execute query. Now I'm going to regen because we have the previous query from before. So now I'm going to double click on current query, and it will remember that I queried just the buildings, and I'll execute query. There we go. Because my quick view had everything in, and my preview query just adds to it. So the best part about this is when I regen, I cleared out the previous quick view to only get the results of the query. So let's try another item. Let's double click back inside of current query, go back into property query, and this time we're going to say layer value, and we'll say hydrology. Hit OK and OK. Now what happens is I've got property layer equals buildings and property layer equals hydrology. I should get nothing out of this. Nothing should query because it can't be on both. So let's look at that. See, 0 objects have been queried if you look at your command line. That's because it can't be true. You can't have something on one layer and another. What would have been better is if I chose or. But what I should do is just clear the query, go back into property, pick on layer, and choose the 2 layers I want right here. So I'll pick on hydrology and buildings. I'm holding down the control key to pick buildings and hydrology and hit OK. So basically what you see, the value equals buildings comma hydrology. I'll hit OK. So now the layer equals those 2 rather than having that weird combination. I don't need to build a complex query type because by choosing layer, I'm able to select multiple. So let's execute that query and see what happens. Oh, sure enough, the hydrology is there as well as the buildings. So if I want to pick on any of these things, you'll see it highlights the whole thing. I'll hit escape. Now I'm going to regen again, and it wipes everything. Let's go back into the current query, double click. It remembers everything I've done. It says the layer equals buildings and hydrology, but this time I'm going to go in draw mode. So now I'm in draw mode. I'm going to click execute query. Takes a little longer because it's actually physically drawing the objects into AutoCAD. So now if I pick on a building and I go properties, you can see, yes, there it is. And that building is inside. It's a closed P line and it's on a particular layer. Now I'll hit escape. Let's pick on the hydrology. I pick on that and I go to properties. And sure enough, there it is. It's on a layer called hydrology and it's blue. And I've actually queried in all the data. Again, if I edit any of this data, it will save back to the original source drawing. Now I can do a quick view of the streets just to see, quick view. And that brings the streets in the background, although I can't pick on them. I'd have to actually go in and re-query. So I'll go into current query and say, you know what? I'm going to edit this current query and I'm going to go to the values and I'm going to add streets, hold down control and hit OK. And OK. Now you see buildings, hydrology, streets are all going to be drawn in my current drawing. I'll hit execute. And now, if I pick on a particular street and look at the properties, sure enough, there it is. It's on layer called streets. The one thing the streets have that the other two layers don't have is object data, and this has object data attached. So AutoCAD properties are a useful way to filter data from your attached source drawings. After querying data that meets your property criteria, you can then use other queries to answer your questions about that particular data. Having intelligent source drawings that are laden with object data is an effective way to keep track of non-graphic information, such as install date or pipe type. Using object data queries allows you to capitalize on this rich data by enabling you to ask questions. For example, you can now ask, show me all the pipe that's older than 80 years by using one of these object data queries. Let's try one now. If we open up our Guelph.dwg and attach a drawing, so we'll hit attach, and we're going to attach the streets to it. I'm going to make sure I'm using the alias called exercise files, which actually points to my desktop. And there's a folder called exercise files, which I extracted from LinkedIn Learning. I'm going to pick on chapter 3, lesson 4, so 0304, and we're going to attach streets. Now, I happen to know that this streets DWG and this location has object data. It actually has the street name. So I'm going to query a particular street based on its street name. So let's click OK. And we'll just do a quick view and zoom to the extents just to give an idea of what's inside the source drawing. There we are. So Gordon Street is a long street that follows the entire length of this city. It starts at the top and goes all the way to the bottom of the city. So we're going to use the current query, and instead of using a location or a property query, we're going to choose a data query. Let's try that. Data, and not an object class, but object data. And right away, it finds the object data table in the attached source drawing. Now, I could use other things like object properties, like a particular polyline or anything like that. So these are AutoCAD objects. It's very similar to the properties dialog. A particular block attribute, but there's no blocks in the source drawing. A database link if I had a link template, but we're really interested in just the object data. That's all we have in these drawings. And this streets table only has 2 columns. It has a feature ID and a street name. Now the street name we want is called Gordon Street, but I want to show you something else. Now feed ID is a numeric, so it allows me to say greater than, less than, equal than, so on. Where street is a string, so it only has equal. That's it. You can't say where it begins with something, where it ends with something. There's no wildcards with object data. So object data is a little bit limited in this way when it comes to querying. What is really powerful is the SQL, and you look at that in another lesson. But object data is very simple. So for a number, we can go less than, greater than, but for strings, it's got to match exactly. So you have to know what the string is. Now, I happen to know it's all uppercase and it's Gordon ST. So that's the name of the street. So I happen to know that's exactly how it's spelt in my particular data set. And it has to be spelt correctly and right case sensitive with the object data, or you won't get a match. So I'm going to do that. And that's the limitation of object data, especially when it comes to strings. When you're querying, it has to be exact. Otherwise, you won't find it. Okay, so we've got street equals Gordon Street, and that's all uppercase with a space. Let's hit OK. And just to make sure this works, I'm going to make sure I'm in preview mode and click execute. Aha, there's Gordon Street right there. Now, if I pick on I can't, and there's no data, like if I look at properties, you'll see that it's an ADE preview object. It really doesn't have any data attached to it. It's just a preview object. In fact, if I hit regen, it disappears. So let's go back into that query. I'm glad I got something back when I chose street equals Gordon Street. But to really see that data and actually work with it, I have to put it in draw mode, and then I'll execute query. Now it says 34 objects were queried. So there's a lot of segments of this road. Now I picked on that one segment right there, and if I scroll down and look, you'll see, aha, street is Gordon Street. So that query did work. I was able to pull this one street using an object data query from the streets.dwg. So querying graphics based on the attached object data quickly shows the information you require. Once the data is drawn in your new project, you can plot, print out a PDF, or export this information to share with other users. If your attached source drawings are tied to a database with a linked template, you can query the graphics from those source drawings based on a number of criteria in the database itself. This is by far the most powerful query technique for performing source drawing queries. But if you have a linked template that ties to a database, before you even attach those drawings, you should attach the database first. In this case, we're going to attach the zoning query access file. That's found on Chapter 3, 0305, Zoning Query MDB. So I'm just going to drag and drop that into my Guelph.dwg drawing. And there it is attached. The next thing I'm going to do is I'm going to attach the source drawings. In this case, I'm going to attach a drawing that is the parcels. So I'll go to my exercise files alias that points to my desktop exercise files. Go to Chapter 3, 05, and we're going to attach the parcels. Now this particular parcels DWG has a linked template that points to the zoning query. Let's click OK. Excellent. So now we have a database attached. We've got our parcels attached. I'm just going to do a quick view and wait for a second, and then I'm going to zoom extents so we can see it. There it is. There are all the parcels for my city. Every single one of these are connected to the zoning query database through a linked template. Now the linked template won't show up until I perform a draw query. It'll eventually show up, but it's not there now. It's in the source drawing. I do have a live connection to the database, which we will use for the query. So let's double click on current query. And the type of query we're going to do is a SQL. We could use location, geographically, a property, some kind of AutoCAD property inside the drawing, like a layer or color. We could use data, which is normally the object data or something like that. Well, let's have a look inside. We've got object data, we've got attribute data on a block, we've got object properties and things like that, as well as the simple database link, meaning just the parcel ID you can query. So with the data query, you can actually query the database link itself because the parcel ID is attached to each object. Not the other data in the database, but just the parcel ID. But that's not what we're doing today. Today we want to use SQL. So we'll pick on SQL and you'll see there's the zoning query link template that's already been set up. And what we want to do is bring in a particular zoning type, just the residential properties. So let's pick on zoning and we'll use like. And we know that residential property begins with a capital R. So go R, and to do a wildcard is a % sign. So any of the zoning that begins with an R will add that condition. So let's do that and hit OK. Leave it in preview mode and we'll execute the query. So those are the buildings or properties that show up with a R category. So they're all residential. Oh, I happen to know that there's a couple in there that are actually designated road, and that begins with an R. So we're going to have to tweak this a little bit. Okay, so we already have this SQL query, and let's edit it using the edit button. And we're going to add another condition. And we'll say, and the zoning is not equal to the value road, R-O-A-D uppercase. Good. Okay, so in zoning it's not like road. Okay, we have one last item to do, and we'll say and not zoning like, and this time we're going to say railroad, RR%. So it's a bit of a complex query here because the first thing we're going to say is like, give us everything that begins with R and not like the word road, or and not like, and that's what the greater than less than is like. But we can also say and not like RR or anything that begins with RR, which is railroad. So we're basically saying give us all the residential. Remember, roads and railroads are not part of that. So we'll filter all that out. We'll hit OK. We'll execute query again in preview mode. And we should have a few less data connected in here. It takes a moment because it's going to the database. And sure enough, it queried in all the residential. Now this is still in preview mode, so if I regen right now, if I just go regen on my command line, RE, it all disappears. So in order to make this permanent, or at least editable, I changed this mode from preview to draw mode and hit execute. And then it goes back to the database in draw mode. Now watch what happens in our task pane. Once it's finished querying, you're going to see something new that shows up. Aha, the link template appears now. So the link template didn't exist prior to a draw mode query. So we have the database attached, but we didn't have the link template available in the query. But now we do, because now if I zoom in and select any of these parcels and look at the properties, sure enough, the zoning is R1B, which is a particular residential zoning designation for that particular parcel. So we were able to use the database, make quite a complex query to only get residential and filter out roads and railroads in order to draw them to our map. So we now have the closed polylines that are linked to the database in our current project queried from the source drawing called parcels. Now, often the database information is maintained by another department or agency. Frequent queries using the attached database keeps the project up to date without you having to maintain the attribute information like one does with object data. If it was an object data, you'd only be able to edit that data using AutoCAD Map. Whereas if it's in a database, anyone can edit that data. Inserting raster images, such as air photos, satellite images, and scanned maps, add context to your drawings. Many organizations scan thousands of drawings from paper, and you have the ability to add those drawings as images to your existing drawing. Let's insert an image now. Under the Insert ribbon, under Image, click the Image button. This map insert looks for all types of images. We've got the options to insert Photoshops, JPEG 2000s, and so on. Even Mr. SID and ECW. In this case, this is a Guelph UTM 17 NAT83 TIFF. This is a GeoTIFF. It's different than a regular TIFF because the metadata inside the file keeps track of where to insert that into the real world. That's the great thing about that. So when you see modified correlation, this will actually harvest all the metadata, all the data about where that should be inserted from inside the TIFF file itself. So if I click open right now, it actually looked inside of the TIFF file and found its insertion point in the world, and that represents a UTM location. So that's a particular coordinate system in meters. It even knows what the density of pixels per unit is and that the units are indeed on meters. This is all being harvested from the GeoTIFF. The difference between a TIFF and a GeoTIFF is that a GeoTIFF has that metadata inside the file. Now, you can also have regular TIFFs with a TFW or world file that's attached to the TIFF. So you could use those as well. In this case, we're going to just be using the GeoTIFF. Now, if you hit OK, we now have the image inside the drawing. But I want to put the image behind the city limits. So I'm just going to pick on the edge. In order to modify an image, normally you pick on the black frame around a particular image. So let's right click on there. And then we'll say, draw order, send to back. By doing that, it sent the image behind the red city limit outline. So now that we've got that, we can actually see that if I zoom in, you could see that the city limits are that red outline and the rest of the image represents farmland. Now, when I first inserted this image, I'm going to just pick that again, and I chose Insert Image. I did have the option to check Show Frame Only. That Show Frame Only inserts a reference to the image, but doesn't actually show that image until later. And what happens is it creates a link back to the original file, but does not show it, and it speeds up my map significantly, but you don't actually see the image yet until you want to turn it on. So if you're adding multiple images, this may be of use to you just to keep things quick when you're panning and zooming so that you don't actually see the image till you really need it. But in this case, I'm only adding one image, so I was able to leave it on. Most raster images require this form of spatial referencing if you want to automatically locate it in the correct location in your existing map. Always ask what coordinate system the image is in before trying to add it to your drawing, or it may end up in the wrong location. Often, raster images may have different colors or may be too big for the map. Using color correction and clipping tools, you can perfect the look and feel of the images inside your DWG. First, in the Guelph.dwg, I have two images inserted in this area. I have one that covers a bit of the southern part of the city and part of the north part of the city. In the southern images, If I double click on the edge of the southern image, I get the image adjust dialog box. I can adjust the brightness, the contrast, and the fade in and out. So if I set the fade to say 5, the contrast closer to 50, and the brightness to about 60, I get a completely different look and feel of my image. In fact, it's a little bit lighter than the one on the north. Now, I also need to set my images behind the boundary of the city. So I'm going to highlight both images, right click, use draw order, and send to back. Now you can see the city limits. The next thing I'm going to do is crop the image so that you only see the bit of the image that's inside of the city limits. We're going to do the same for both images, the upper and lower one. First, we pick on the lower one, and you'll see the context sensitive ribbon appear at the top. There's an image ribbon, and what we're going to do is click on the create clipping boundary. Now we're prompted to select a polyline or do a rectangle box, but we're going to actually type S and press enter. And we're going to pick the city limits, and you'll see that the image is now cropped by the city image. Let's do the same for the top image. So I'll highlight the top image. I'll pick on create clipping boundary. At the command line, I'll type S for select. With my mouse, I'm going to pick the city limits again. And sure enough, both images have been cropped to the city limits. Even though I have two images in this drawing, both are cropped to the outline of the drawing. Now, modifying the raster images in your drawing does not permanently modify the original image. These still link to the original images. They have not changed brightness or how big they are. That stays constant. The settings are stored within the individual drawing where the image is inserted. To permanently modify the image, it is recommended to use a third-party image management tool such as AutoCAD Raster Design, which works as an add-on within AutoCAD Map 3D or Civil 3D. As an alternative to using the attached drawing queries, you can use the Display Manager to query drawing information, both in attached and currently in the drawing. This drawing data technique in Display Manager has the advantage that the information queried can be toggled on and off as a separate layer within the Display Manager. Let's try that now. So we're going to attach two drawings to our current drawing. So we're inside of Guelph, and you can see the city outline in the background. I'm going to go into the 501 folder, and I'm going to drag the buildings and the streets into my Map Explorer. So let's just drag that in to Map Explorer. Now I get a dialog box that says, what kind of alias do you want to use? Do you want to use the C alias or the previously created alias called exercise files? I've already created that, so I'm going to choose that one instead. That points to the files on my desktop, so it knows exactly where they are. So I'll do that, and I'll do this for the second drawing. So it did it for the streets, now it's doing it for the buildings. Again, picks exercise files, and done. So by dragging and dropping those two drawings into my Map Explorer, they're now attached. I'll just do a quick view so you can see where they are and hit OK. And sure enough, there's the buildings and the street. So that's what we're going to base our queries on. So I'm going to regen just so they disappear. Now, normally at this stage, I would go into the query library and I would do my property or location queries and so on. But what I'm going to do different in this case is I'm going to use the Display Manager to pull that data out. So instead of using Map Explorer in the current query, I'm going to use Display Manager. Now what I can do is under Data, there's a Data button there, and I could say Add Drawing Data. So if you look at the list, I've got all sorts of object class, topology, and so on. But then I have this one called Query Source Drawing. Now I can query the current drawing. That means if any layers already exist in the drawing. But in this case, I've just attached two source drawings, and that's what I'm going to query. So let's do that. So I have a dialog box here, pops open, and what do I want to query? Actually, I just want to get the buildings. So I'm going to go into the property. I'm going to pick on layer, and I'm going to browse the source drawings for the layer called buildings. There it is, buildings. I hit OK and OK. And this dialog box looks almost identical to the data we do in the attached drawings. But we don't have a query mode options here. We only have draw. We don't have preview or anything else. So, and we don't have execute queries. So we don't have that, and we don't have execute query, but everything else looks the same. So what I'm going to do is I'm going to click OK, and it should query the source drawing for the layer buildings and add it as a new layer in my task pane. There it goes. It queries the source drawings and should draw the buildings. And there they are. There's the buildings drawn in. So what I can do is rename that layer so we know exactly what it is. So we'll go in here, and I'm just going to call it buildings. And what's great about buildings is that I now have a queryable layer that's coming from source drawing that I can actually just turn off and on. So the entire query is toggled on and off. The map base is the unstyled everything else in the drawing. So basically the only thing else I have in this particular drawing is the city limits. So if I turn off the map base, the city limits will disappear and will come back. As simple as that. So we've got two different layers. We've got a query layer. So this is coming from the source drawing. And then we have the map base, which is everything else in this particular DWG. That's what map base is, everything else. Okay, so I want to do the same for the streets. So let's go to data, add drawing data, query source drawing. So again, we're going to connect to the drawings that are attached to this particular project. I'm going to use property. I'm going to pick a layer again. I'll choose values. And this time I'm going to pick streets. Click OK. So now we have layer equals streets. Property, layer equals streets. You know, there's no preview mode or anything like that. And there's no execute. You just hit OK. And sure enough, the streets should be queried in right now. And they are. They're being queried in. And what I'm going to do is I'm going to rename this layer to streets. And I could toggle the streets on and off simply by a checkbox because it's a separate layer. And same with the buildings. And again, if I turn off the map base, it'll just turn off the city limits and no other layers. So now I've got three different ways of looking at my data. I can just look at buildings, just look at streets, turn off the map base, and so on. So by doing this, it gives me a pre-canned query that I can toggle on and off directly from my source drawings. And what's interesting is I can actually query the current drawing. So if I actually want to pull out the city limits there, I can do that too. In fact, I can go data right now and go add drawing data, and I can query the current drawing. And I could do the same thing, property, layer, values, and the city boundaries there. So I can pick that. And now I hit OK and OK. And I'll just call this city boundary or city limits. There we go. And I bet you if I turn that off and on, I've now got ability to toggle the city limits as a separate layer. So the city limits is coming from the current drawing, and the streets and buildings are coming from the source drawings. So I've broken it all out by pre-canned queries. So in Display Manager, querying drawing data and creating drawing layers is a quick and powerful way to have a layer that is dynamic based on the query and toggleable since it appears to be as a layer separate from the rest of the data. Each drawing-based layer in the Display Manager will use its source feature style. For example, gray roads are shown that way because the object color is defined as by layer in the original DWG. Luckily, you completely override this with red polylines if you define it in the Layer Manager. This doesn't even modify the original dataset. It only shows this way in your current project. Let's give that a go. Now I've opened up the DWG that has some layers already defined. But I got a warning. It says element significant buildings encountered missing the source drawings. So that means I have to make sure that the source drawings are attached. So I open up the Map Explorer and I'm going to drag and drop buildings and streets into my task pane. Make sure they're using exercise files. That's the alias I predefined. There we go. And the same for the buildings. Hit OK. And that's OK. And we can clear that error. Let's go back to the Display Manager. And we'll right click in the workspace here and hit update. And we should see the significant buildings and the major streets appear. There we go. And that's the leftover error. And I should just go in and clear those errors because I've already fixed the data connection. Great. So now we're ready to go. Now, right now, both the buildings and streets are the default colors. Right now, the buildings are a gray and the streets are black. I want to make the streets red, and I want to make the buildings cyan. So in order to do that, I have to add a style to this particular layer. So the buildings that I can toggle on and off here can be styled. So if I right click on here and add a style, in this case, I want a hatch. So I have all sorts of choices. I could say hatch or an entity, which is basically anything such as a line or a P line, or a hatch was a fill or a piece of text or some sort of raster imagery. But in this case, I'm going to pick hatch because I want to fill inside of each of these buildings. So I'll put in a hatch and then I'll change the color of the hatch. So let's see that. Now they should all just hatch every single building. It may take a while because hatches take a lot of memory. And once it does that, we can change the color. Normally it defaults to like a black color, but we're going to change that to a cyan just so we can see what it looks like. In fact, this case, it inherited the master color, which was gray. So let's change that slightly. So we'll go into the hatch style, right click, and go properties. And we get the properties dialog box. And this is where we can change the color. So right now it's the color of layer. So instead of color.color, we're going to go in here and pick a color. And I'm going to just choose cyan. And that should override the fill color. And then you can close the properties dialog box. There, we've actually changed the significant buildings to be a cyan. Now I wanted to change the street color to be red. So we're going to add an entity style to change that. So let's do that now. So if I pick on major streets, I right click and say add style. In this case, because they're line work, I use entity rather than anything else. So get a new entity style. Make sure you expand so you can see it. There it is. You see how it collapses underneath? It makes your legend tidy by collapsing your styles. But if you expand them, you could see them. So there's the entity style. And again, it inherits the default color. So I'm going to right click on entity style, choose properties. And this time the color is going to be red. So I'll just pick red. And that'll override. And then we can close the properties pane. So there we are. We've got red streets and cyan filled buildings. And we can toggle these off and on. Just like this, we can turn off the major streets or turn off the buildings like that. Now, for some reason, the data in the background has changed. So that means we're looking at source drawings. So let me just go back to Map Explorer for a moment. We can see that we've got streets and buildings. But what if someone else has this data attached to their drawing and they're updating some of the streets or updating the buildings? To see updates, you just have to either right click on the one layer and click update. And I'll do that for major streets. And what it will do is go back to the original source drawing and pull in all the changes to your current drawing. You could do that individually for each of the layers, or you can right click and do an update for everything down inside of the task pane. Okay, so one more thing I'd like to change is how this is represented. The buildings are actually polygons, but it's showing a black line. So how we can fix that is we just right click on the word significant buildings. We go to properties. And instead of the thumbnail preview being a line, we could actually say it's a polygon. And you can see now the buildings are cyan polygon, which is much more accurate. Now let's pick on the major streets. Now it is a line, but what actually looks nicer is a polyline. The polyline is actually a nice curvy line like that. So there we go. So now our legend shows a wavy major street polyline and a hatch style significant buildings. And again, we can toggle these on and off at any time, and they are coming from the source drawings. Now the great thing about this is we're not modifying any of the original data. When we change the colors and these entity styles, this is just putting a lens on the data in our particular project, in this Guelph project. The original source drawing is not being changed in any way. This is how we're looking at it. We're just painting it with our paintbrush, but it's not actually affecting the original data. So the data will stay gray or black or whatever the original color was, but in our task pane, we have a way to override it. So perhaps I want to print it a certain way. I don't have to copy the layer and change the colors. So a lot of process for plotting is making duplicate data just to get it to look the right way for printing. But here we are using the display manager to get the data in a different way so I can display it in a completely different way for plotting or printing or anything else you want to do with that data. Using styles for drawing-based data layers is an effective way to stylize DWG-based data without permanently modifying the original or having to copy the original just for that map. This is what happens most of the time. Importing GIS data converts the various industry standard formats directly into an AutoCAD object. Most GIS data has a rich set of attributes attached, so to maintain this, we would store those attributes in object data. Once we import the data, the original data is no longer necessary or used, so we don't need it anymore. In this case, we're going to import a shapefile. So let's do that. If we go Insert, and then we go under Import, the Map Import. The command is actually Map Import. You'll see that at the command line. Now under Files of Type, we can look underneath and see all the different type of GIS files we can import. ASCII files, so they could be exported from a GPS machine. We've got SDF, which is used in Map Guide and other formats. City GML, really old type, Esri ArcInfo export, that's really old, same with the coverage. A shapefile, GML, KML from Google, old map info tabs, MicroStation, and so on. So there's a lot of different types we can import here. What we're going to choose is the Esri shapefile, the .shp. That's a pretty common format. So we'll go to our desktop, go into our exercise files. We'll go into chapter 6, number 1, and you'll see 0601, there's Guelph Trails. This is the shapefile we're going to import into this blank drawing called trails.dwg. Let's pick on OK. So AutoCAD interrogates that shapefile. It sees what the coordinate system is, and it sees that it's pseudo Mercator. That's the Google coordinate system. You'll see that coordinate system come up quite a bit. So the WGS84 pseudo Mercator is basically the Google projection system or web Mercator. So that's just the Autodesk version, WGS84 pseudo Mercator. So you'll see that a lot. One of the first things we see is the input layer. So this is the import coming from the shapefile. It's going onto a layer called Guelph_Trails. That's fine. If there's any other layers in there, they'll be listed in the drop down here. So you'll see city boundary 0, but it's going to create a brand new layer called Guelph Trails. That's fine. There's no object class. The coordinate system is inherited. That's fine. Now what we really need to do here is choose the data. So we know that the Guelph Trails will go on the Guelph Trails layer. There's no object class. The coordinate system matches the drawing. That's excellent. And the data. Now, remember when you pick in here, there's a tiny little button that appears. So I pick in there and I pick on the tiny button and this will give me another dialog box. This is the attribute data dialog box. So we could choose not to import attribute data. If I do that, only the graphics will come in from the shapefile. So it's really plain. It's just the line work and that's it. But I actually want the object data because shapefiles are pretty good because they have all this extra attribute data. So if I say create object data, it will create a table with the same name as the layer, which is actually really handy. And if I click on select fields, it's going to interrogate the shapefile and tell me what kind of data that shapefile has. If I click on select fields, so it's got 4 different columns. It has a feet ID, a name, a level, and a layer. So these are just some of the columns inside of it. I'm just going to leave them alone and hit OK. So it's going to create that. Now I do have an option to create a unique key field. So it'll just auto number a number. So I could actually add that and say add map key or not. But there actually are some already in there. That feed ID that's inside the shapefile is already an auto number. So I don't need to do that. But sometimes you can import a file and it doesn't have a unique field. So this can assign an auto number to it. And then it's there. But once it's in the object data, there's no auto number field in the object data. So any subsequent numbers or new data you add, you have to manually type it in. So this just is a one-time shot where it loads it up with data. Okay, let's hit OK. So check. We've got the input layer, Guelph Trails. It's going on the Guelph Trails layer. It's in the right coordinate system. All the data will be dumped into an object data and points. Now, if these are points I'm importing, I can overwrite it with a point or a block or even put text in that spot, but I'm not going to be doing that. These are lines. These are trails, so I don't need to worry about the points. Another important thing to look at is this checkbox down here. Import polygons as closed P-lines. Now inside of AutoCAD Map, there is an M polygon object. And if you have closed P-lines coming in or polygons coming in from a GIS, it'll actually draw them in M poly format with a built-in hatch. So often you want to import it as a closed P-line because AutoCAD Map really likes to treat polygons as closed P-lines. So this I almost always do when bringing in polygons. But remember, these are Guelph trails, so I don't have to worry about this checkbox. But just be aware of this checkbox in case you're importing anything that's a polygon. So let's go ahead and pick OK. So I brought all 391 objects in. You can see that down here. In 1 second, there they all are. There's the Guelph trails. In fact, I can go to the trail and actually make this a nicer color. So I'll go to my layer manager. This is just AutoCAD. And I'm going to just change the color for that particular color to green. So that's green. So there's my green Guelph trails. What's really important about these trails, after I've imported them, I don't need the shapefile anymore. I've got this DWG called trails that has everything I need in it. And if I right click right now and go to properties, you will see there's now object data attached that got imported from the shapefile. It's already got the feature ID, so that's the unique ID of that piece of trail. It has the name, Speed River Trail, and the layers off the state highway, for example. So let's look at another piece of trail, maybe farther into the city. Maybe right here, let's look at this. So there's a long bit of trail there. So if I pick on that and we scroll down to the object data, oh, that's the Hanlon Creek Trail, and it's on the layer trail. So there we are. So we've got this data that's come in from a shapefile that is now completely part of our DWG. I could save this and give someone this trails DWG, and they can open it up and get all this data from the trails. We could also export this to another format if we wanted to, using a map export. The nice thing about shapefiles, though, is that AutoCAD Map actually reads it natively. I could have dragged and dropped that shapefile directly into my current session and been able to look at it and edit that data live. But in this case, it's an actual DWG that can be shared. I don't have to share the shapefile as well. So you have two options. You can either import the shapefile or drag and drop it in. But in some cases, it's better just to have the graphics inside the AutoCAD, so you've got a P-line that you could play with rather than having to worry about editing the live GIS. So now that you've learned how to import data, you can take most GIS formats and convert them into a format that all AutoCAD users can now access, the DWG. Sharing DWG data with other GIS systems is part of the full design cycle within most organizations. Many standard formats, such as Shape, Map Info Tab, SDF, MicroStation GGN, are all available to export. We're going to export our Streets DWG out to an SDF file. This format is common across Autodesk, as well as other open source platforms such as MapGuide. Let's zoom in and look at these streets. If I pick on one of the street segments and I right click and look at properties, we have all sorts of data. We have the layer it's on, the line type, the material, and so on. But some of the things that are most important is that we've taken the time to put the name of the street and a feature ID on each one. I want to make sure when I export this to an SDF that we capture the feature ID and perhaps even the color or the layer it's on. Okay, how do we export? Well, under the AutoCAD Map 3D logo, click the down button and you'll see the export menu. And we can export as another DWG or DWF or even an SDF directly. But let's look at the other GIS formats for now. It defaults to Autodesk SDF. I'm just going to put this to our desktop. And we can see it can go out as City GML, ArcInfo Coverage, Google KML, and so on. So we can export in all sorts of formats. But the main one I want exported is as an SDF. And we'll just call this streets.sdf. And I'll just put it on the desktop and click OK. Now, what layer do I want to export? So the very first thing I have is under the Selection tab. The Selection tab tells me, what am I exporting? Do I select everything, or do I filter it, or do I pick it manually? In this case, I'm going to select everything on a particular layer. So under layers, instead of a star, I'm going to hit the layer button and choose streets because I'm not exporting 0 or the city boundary, just streets. And I hit select. That's all I need to do at this level. So let's go to the next tab, feature class. So it's going to export a single class from what I've selected. It's going to put it on streets because that's the name of the layer I'm exporting it as, and that's fine. I could call it streets. And what kind of geometry are the streets going to have? Well, we have lots of choices. Is it going to be a single point layer, a line layer, a polygon, or is it a combination? Now, some GISs can't support the combination. For example, if you're exporting to a shapefile, it can only be point, line, or polygon. But if you're exporting to something like an SDF or a bigger database like SQL Server, it could be a combination of anything. It could be all three, point, line, and polygon, in the same layer. In this case, these are just lines. So we'll just choose line for the streets SDF. Before we move away from this area, as we're dumping out the streets feature class, we want to make sure we're getting the object data. So if we look at the select attributes, we could go in here and we have different properties. We have the properties, object data, and the object properties. Most of the properties and object properties are purely AutoCAD only. The object data is an AutoCAD map thing. So that's what we want. We want to export the feed ID and the street. So let's go ahead and do that. We'll click OK. So now those two properties are going to be exported. I may also want to pick something else, like the layer it's on, but that's just going to be on the streets layer. But I could change all sorts of things like line type and line weight. I could take the style or the string if it was a text, or the very first X and Y. So I have a lot of options here, but I'm going to just stick with the object data for now. Okay, now it's time to go to the Options tab. Now, right now, it thinks it's in WGS 84 Pseudo Mercator, and that's fine. That means it's in the Google projection system. But what if I wanted to give someone a shapefile in a different coordinate system? Well, you pick on here, and you could browse to any coordinate system that's listed in the Autodesk library, in the coordinate system library, and you could pick on any coordinate system. I mean, it could be a state plane like California, or so on. So there's all sorts of coordinate systems, but we're not going to use that. We're going to leave it as WGS Pseudo Mercator. That's the Google coordinate system. We're going to leave that alone. We don't need to treat closed polylines as polygons because these are line work. They're streets. We don't have to worry about that. But if these were buildings or parcels, I would definitely check that. There is one more step that we can take. It's up to us. We could save all this work we've done and save it. I'm just going to put on the desktop. And I'll just say, export streets EPF. Now, an EPF file is an export file, and that allows me to save all these settings that I just did so that I could load it at any time and publish this data again. So if you're finding that you're exporting out to another GIS often, you could save a profile on your network, load it up. I can go and pick it off my desktop again. There it is, export streets EPF, load it, and it will make sure all these settings are the same as what we just picked. And you could do that for all sorts of export import procedures, the load and save. The import and export both have load and save. Okay, so what happens when we export these streets SDF? We hit OK, and all 3,100 were exported. So if I go to my desktop, I should see that file. So let's go to my desktop. And there's the streets SDF. Just to make sure it worked, we can open a brand new drawing and drag and drop the streets SDF into our current AutoCAD Map session. And there it is. It defaults to yellow. That's okay. And let's pick on a segment. Right click and look at properties. And sure enough, the feed ID and the street are available. We captured everything. It's now an SDF file that anyone could share with. I can send someone this SDF file and they'll have the streets with all the data attached. So attribute data such as object data and link templates can be used to create GIS data with associated attributes. In fact, GIS data without these attributes are not as effective as data with the attributes. AutoCAD Map can import and export many formats, but one of the most effective ways to working with GIS data is to attach it directly rather than importing it into your drawing. To attach GIS files and databases to your drawing directly, in Display Manager, click on the Data button and click Connect to Data. We have so many choices here in the Data Connect list, and you'll notice different icons. ArcGIS Data Connection, you'll see the icon looks like a little database, and that's what it is. You'll have ArcGIS Online Connection. You'll have to use the ArcGIS Connector dialog box in the Autodesk Connector for ArcGIS. We'll look at that in another lesson. Another database is Industry Model Connection or MySQL ODBC. Oracle, you can connect to anything Oracle, especially Oracle Spatial. Progress as well. Or a raster image or surface or LiDAR, you can attach it here. SDF or Shape, those are two file-based ones, as well as a SQL Server, which is any SQL Server database that has spatial data type, you can connect to it. Doesn't even matter if it's an SDE database or any other kind, you can connect directly to it. A SQLite connection. And then we have the other types of web-based connections, such as WFS, WMS, WMTS. There's all these different types of connections. Those are all the OGC ones. What I want to connect to right now is a shape file connection. So I'm going to call this one Shape Exercise. And the folder I'm going to connect to is in Chapter 7. So go to our desktop, Exercise Files, Chapter 701. There we go. And I have a choice here. I could choose a folder or an individual shape. The nice thing about the folder is this data connection, so I can refer to it as shape exercise, will always look into this one folder for all the shape files that happen to fall within it. So I can have multiple shapes on one connection. So I don't need a separate connection for every single shape. I just have this one connection, looks in the folder, and I can pick the ones I want. I could do individual shapes by hitting the single shape browse button here, but I'm not going to. And there is only one shape in there. That's the point of interest. But I'm going to use this folder connection again. Make sure it points into 701, hit OK, and then click Connect. And what it'll do is it'll read that directory. You can see the list of the directory at the top of the screen. And it's a point of interest. It shows you what coordinate system it's in. Yes, it's in UTM zone 17. And I'm going to check default, yes, and click Add to Map. And what will happen is it'll actually add this points of interest shapefile to my current map. So let's go ahead and click that. And I'll close this dialog box. And you can see there's my point of interest as dots in my map. Okay, so that didn't import. That is actually a live connection to a shapefile that happens to be on my desktop. So that means if anything changes in that shapefile, it'll be reflected here in my DWG because it's a live connection to that file. Let's connect something else. This time we're going to connect another file format, but it's going to be an SDF. Now this one I'm going to call SDF exercise. And let's browse to the same folder and grab the curbs. So I'm going to be bringing in the curbs as this data connection. Now you'll notice, unlike the shapefile, you only have a file browse button. I don't have a folder browse button. Shapefiles have a folder. The reason that is an SDF is a very special data type. SDF can contain many themes inside of it. It could have curbs and sidewalks. It could have other points. It could have meters. An SDF is basically a mini database that can contain many different types of themes. So it doesn't need a folder to look for a bunch of themes inside of it. The SDF has themes inside of it. So we don't need the folder. So that's why we just connect to the curbs. Now, there's only one theme inside this one SDF, and that's fine. But sometimes you could just call it city.sdf and have everything in one SDF. So just keep that in mind. So let's connect to it. And again, there's the curbs. Oh, it's in a different coordinate system. If you remember, the points of interest were in UTM. This is in actually the pseudo Mercator. That's that Google coordinate system, which actually the current map is in. So that's fine. And I'll click Add to Map. So let me close my data connections. So there we are. We have points of interest and curbs. Oh, I'm going to drag the points of interest above my curbs so they're not being obscured by the curbs. There we go. Now you can see all the teal dots as the points of interest. You can see all the curbs in the city. If I pick on a point of interest, you'll see, use properties. You can see that, oh, that's WC Wood Company and feature ID is 18. Now if I hit escape and pick on one of the curbs, the only thing the curb has is a unique ID. There's no other data attached to the curbs. So there you are. So again, both the curbs and the point of interest, a shape and an SDF, if anything changes in the files, whether the shape changes or the SDF changes, that will be reflected in my DWG. So it's using those files as a separate entity, almost like a linked document or an XREF. But basically the GIS data becomes an XREF in my current session. It's live streaming. I have access to everything. So connecting directly to vector-based GIS data is a great way to share information between systems without even having to translate or duplicate any effort or the data itself. Connecting to raster data using Data Connect enables you to add one or more images to a single layer. Raster images, such as air photos, satellite, and scan maps, add a large amount of context to any drawing. In the Display Manager, if you click Data, Connect to Data, you'll find the Add Raster or Surface connection right here. For the raster name, I'm just going to call it Raster Exercise. Now we have a choice, a source file or folder. We can connect to a single raster image or a folder full of raster images. Now we're going to point to a folder full of raster images because we have multiple images to add at once. They're all the same coordinate system, so that's perfect. By the way, if you are going to do this technique where you add multiple raster files to the same layer, they all have to be in the same coordinate system. So let's do that. So browse to your desktop, Chapter 7, O2, and pick on raster. Click Connect, and it will see two raster files in there. I'm going to expand this so we can read it. There we go. You can almost see the whole file name. There we go, a little bit bigger. There, we've got the north and south raster images that we're going to add. So we'll check TIFF for both, but we're going to have to override the coordinate system. So click on coordinate system. You'll see it doesn't know what it's in. So what we'll do is we'll click edit for the default. And I happen to know this is in UTM, so I'll just type it UTM 1983, zone 17. And we'll pick that and hit select. And we'll pick the second one, hit edit. Pick UTM 83-17 for the second one. Now, no matter what, if it finds it in EPSG 32767 or if it's in default, it'll override as UTM 8317. Perfect. You could hit edit if you want and go back, and I'll just close that up or click OK. So now you'll see the coordinate system is listed here for the north and south one. Now, I don't want to have two different layers added. I'm going to combine them into one, and I'm just going to call it raster. There we go. So we've got the north and south, and the nice thing is someone named these files with the coordinate system in mind. See, it said UTM 17 NAT 83. Very good. So that helps me because it's always good to know what coordinate system your raster's in. This is really critical. So if someone gives you an air photo, first thing you should ask them is what coordinate system is it in? Okay, let's click Add to Map and see what happens with these two raster images. Now we can close the data connection in the background. And there's our two images. I turn them on and off. They're actually two completely different images stitched together as one layer. Now you'll notice that they're underneath. If I turn it off, you'll see the city limits. Now that's part of the map base. That's a DWG map base layer. The raster is an FDO, one of these data connection layers. So I have to move the map base above the raster to see it. So let's just drag the whole map base above raster. Oh, sure enough, there's the raster underneath the data set. This is a really nice way to manage your data. You don't have to run around turning off and turning on each individual layer. You can just turn on all the layers at once or turn them all on at once, which is great. So all images added using the Data Connect technique still require that they are georeferenced into a particular coordinate system. Raster services also known as elevation models, store the 3D coordinates of a surface of the Earth. These surfaces can be added and combined into a single layer. Adding a surface to the map is best viewed in 3D mode and will automatically drape all the vector-based GIS layers over top of it. Let's add a DEM now. In our drawing, guelph.dwg, we're going to add a new data set. So under Data, Connected Data, under Add Raster Image or Surface Connection, this is going to be a surface connection. We're going to change this name to Guelph_DEM. Now, like the shape files, we have two choices. We have a single DEM file or a folder of DEM files. In this case, we're going to find a folder. So we're going to click Browse. We're going to go into 0703, and there's a directory in there called DEM. Let's pick on that. So it should be in your exercise files, chapter 7, 0703/DEM. Let's go ahead and connect to that folder. There's actually 4 different .dem files, digital elevation model, inside there. We're going to actually select all 4 of them. So check the DEM. You see all 4 selected. And we're going to combine them into one layer. We're going to call it Guelph. It takes the name of the first file, so we're going to rename that. Just say Guelph DEM. And that will combine all 4 of these DEMs seamlessly into one layer that we can toggle on and off. Now, these are in lat long format, but we're going to be reprojecting into pseudo Mercator, which is the Google coordinate system or Bing, basically the web Mercator. So let's click Add to Map. And now we can close the Data Connect window. All 4 DEMs are now added. They're toggled on and off in a single layer called Guelph DEM. There it is. You can just toggle it on and off. You can see underneath that there's a city limits. So what we can do is we could take the map base, which is a DWG layer, not a FDO layer, and we'll drag the map base above the GIS layer called Guelph DEM. So now you can actually see this is the city limits of Guelph. So if I zoom in to the map slightly, there we are, you can see the topography of the city and area. Now, something's really interesting to note here is that we can see the elevations, we can see the river valleys and things like that. What we can see as well are these striations that sort of go north, west, southeast. And those are actually drumlins from a glacier. So this was a drumlin field. So most of the elevation found in this region are from drumlins and some river activity and flooding. Okay. What really helps us to view this data is to put it into 3D modes. At the bottom of our map, you'll see an icon down there that says switch to 3D mode. We can click on that. Now, apart from the drumlins and some of the river valleys, this area is quite flat. So by exaggerating it, we could see a lot more detail. So for example, I could put up to 10 times high, and I can zoom in and exaggerate the elevations by 10 times. So the river valleys look a lot steeper and the drumlins look a lot bigger. For example, if I put it back to single, you'll watch all those bumps shrink back down to a very smooth landscape by comparison. It's very subtle. Now you'll notice that the outline of the city does not appear. It's not being draped in 3 dimensions. The only data that will drape in 3 dimensions are other vector layers brought in by using the display manager. None of the AutoCAD-based entities, so P-lines and blocks and things like that, won't drape automatically. We have to use GIS-based data, so vector data brought in using data, connected data. That's the only way to bring in vector data that will be draped over top of this data set. So that's the one thing you have to watch for. If you want to drape data over top of your DEM and 3D models, it has to be GIS data, not plain AutoCAD entities. Now, like all other GIS data, the DWG does not store the raster surface within the DWG, but has a connection. Saving the DWG does not affect the live raster surface in the background. Those 4 DEM files are unaffected by anything we do within this session. Microsoft ODBC, or Open Database Connectivity, is a connection to most databases found on the Windows operating system. Connecting to a database with ODBC enables AutoCAD Map 3D to use that database to pull the X and Y values to generate points on a map. To create an ODBC connection to your database, you can go to the Windows search bar and type ODBC. We want to open ODBC data sources 64-bit in this case. So let's click on Open. And we've got the empty dialog box that says ODBC Data Source Administrator. There should be no user DSN values in here right now, unless you've previously set them up. Under user DSN, that's where we're going to work. These are those data source names, that's what DSN stands for, data source names, that are connected just for your username when you're logged into this computer. If you have rights, you can set up a system DSN so everyone on this computer can see them, as well as a file and so on. But we're going to stick with user DSN for now. So let's click Add. We have a number of choices here. We have a Microsoft Access driver for MDB and ACCDB. Those are the normal file extensions for Access. We also have TXT and CSV Access drivers, as well as an Excel version. So these other two are quite powerful because if you have a text file or an Excel file that has some data inside of it, you could use those files to drive points inside of AutoCAD Map. Now, of course, Microsoft Access will be much faster because Access databases are indexed and things like that, whereas text files and XLSs are not. So we also can connect to other formats such as SQL Server, and if you had an Oracle connector, you could connect to that as well. But today we're just going to connect to Microsoft Access Driver MDB. Let's click Finish. Let's just call the data source name Points. And this is GPS points. These are actually trail points on a trail, but we're going to just say points. We're going to select that database. It's on your C, Users, and just find your name under Users. There I am. And then Desktop, Exercise Files, Chapter 7, and 04. So there you go. So under Exercise Files, CH07, 0704, there should be a GPS MDB. We'll select that and click OK. There we are. You should see Database, C, and then Exercise Files, CH07, 0704, GPS. That's all we need to do. And now we can click OK. And you'll see under the User DSN, there's now a Points data source. Click OK to close the dialog box. Now we can go into AutoCAD Map, and in our Display Manager, add a new ODBC connection to that database. So click on Data, Connect to Data. We're going to rename this to ODBC Trail Points, because that's what they are. We have two types of source. We can say connection string, which is the manual ODBC connection string, or we can use the DSN, which we already set up, which is a lot easier because all I have to do is hit this ... browse button here, and there it is. Points are listed. So now, because Windows knows where that file is, we can just pick on that name Points, and it will find it on our hard drive. Now, if I hit Connect, and don't worry about username and password because there's no username and password on this Access file. So we just leave everything blank and hit Login. Sure enough, it found the GPS trail points. It knows the identity is ID. And it knows that there's an X called longitude and a Y called latitude. Now you can change this if you wish, but for the most part, that's how we want to do that. The ID is unique, so it automatically does that. If you want to change any of these, you can switch them. For example, I could swap the latitude and longitude around if I want, but longitude and X goes together. And if you had a Z or Z, you could put the elevation in there. But for now, in that table, we've got an ID and a longitude and a latitude. And using those three things, we can actually draw points on the map. So let's click Connect. And the coordinate system is actually in lat long 83, says unknown. So to override the unknown, because otherwise it thinks it's in the Web Mercator or Pseudo Mercator, so I need to override this. So I'll just click on Edit Coordinate System here and just override it by hitting Edit. I know it's an LL83. So I'm going to pick on here and go LL83. There it is. LL83, hit Select and OK. And now you should see under coordinate system beside the GPS trail points, LL83, click Add to Map, and the point should appear. Let's close this dialog box. Now there's all the GPS trail points from the GPS machine. Now if I pick on a single point and look at the properties, let's look at the properties, and you'll see it's a particular segment ID. You'll see the ID, and lat and long do not appear as feature properties because they're actually being used to generate the geometry. Now what's really neat about this is even though this is an access file with points in it, if I were to move that point or create a new point, it'll write new lat and long back into my Access database. So this is a very powerful way of getting data out of a database where you only have X and Y values and you don't actually have a shape file or any other type of GIS file format. You just have X and Y in a database, and voila, you've got it inside of AutoCAD Map. So using ODBC points is optimal for points that are being populated into a database directly. For example, GPS location systems that are on buses or police cars can send the X and Y into a database directly, and then they can be rendered directly inside of your drawing. We're going to use the Autodesk connector for ArcGIS to bring data in hosted by ArcGIS Online. First though, we need to publish that data online to ArcGIS. So first, we're going to open up the Guelph DWG, and then let's drag and drop the Guelph Trails STF into our current DWG. It will add a vector-based layer showing Guelph Trails. If you look at the trails, I'll zoom in and highlight one and look at the properties. You'll see there's not too much to the trail. It has a level, a name, and a layer. That's about it. So I'll close the properties and zoom out a little bit. Let's close that. And you'll see that is our layer, and I can toggle it on and off. You'll also notice that there's a background map in our current DWG. You may have not seen this before. What's great about the background map is that on the online map area, it's going off to Bing. So Microsoft Bing is generating either aerial, road, hybrid, or completely off. And most of the time we run AutoCAD with that off. But what's really nice is to have this Bing aerial in the background available so you can see the context of your current map and see where it is and how it sits in the general area. So for example, you could see that this area here, Guelph, is in the southern part of Ontario, Canada. Let's zoom right back in. And there we are. Now we're going to publish the Guelph Trails. When we publish the Guelph Trails to the ArcGIS, it's not going to take any data that's DWG. For example, this is a polyline on a city boundary layer in AutoCAD. These won't be published because these are not vector layers. They are not GIS layers. They're not connected using this data connected data. If it's not in this list here, I'm inside the Data Connect window. If it's not one of these, we can't publish it to ArcGIS Online. It wants vector data. So the only thing that will be published if I hit the Publish to ArcGIS is the Guelph Trails. Let's do that now. In the Home ribbon, you'll see under ArcGIS a Publish to ArcGIS. We're going to get to the Autodesk connector for ArcGIS after, but first we need to publish there, and then we can connect to the data that's there. So let's pick on that. And we need to log in to our account. I'm just going to sign out real quick. What you see here is the default URL for ArcGIS Online. It's www.arcgis.com. You need to have an account set up in order to publish, so make sure you go ahead and go to that website and get a free account. We also have the ability to add a new portal. So if you're using ArcGIS Enterprise or ArcGIS Portal, you can connect to that. So your organization may have ArcGIS Enterprise, and you could put in the URL for your portal instead. But today we're going to be using ArcGIS Online. So I'll just leave it as the default, the www.arcgis.com, hit connect. And it'll ask you to log in, and I'll put in my username. This is my username. And it should log me in. There we are. And then it says, what do you want to publish? And the only layers that will appear in here are those that are in your task pane that are vector data GIS based, not any P lines or anything on the AutoCAD layers. So we'll pick on Guelph Trails and hit OK. Next, we're going to pick on the area of interest. That's fine. Let's click Next. And you'll see this is our SDF file. It's got a feature ID, name, level, layer, geometry. We'll just leave all the defaults and click Next. Let's give it a service name. In this case, I'm just going to call it Guelph Trails. And they were GPS, so I'll put GPS. And I'll just put in some notes. Guelph Urban Trails. And the tag will be Guelph. Hit enter and I'll type trail. So there we go. Oh, we need some advanced settings. Who can edit this data after we upload it? We'll say add, update, and delete features. And who are we going to share it with? Everyone? No, I don't want to share with everyone. I only want to share within my organization. Or if I had any groups set up, for example, I've got test groups set up, but I'm just going to share with my organization. Hit next. And I'm going to put it in a folder. I already have a folder set up called Guelph. So then I'll hit publish and off it goes. What's happening here, it's actually taking the SDF file and it's converting it into a file geodatabase on my hard drive. Then it bundles it all up. So if I had multiple layers in my legend, it would take all those different layers, compress them into a file geodatabase, and upload that file geodatabase to ArcGIS Online, and then create a layer. So it's doing all that with the Publish tool. So I can view that layer in ArcGIS. I'm just going to hit close and actually manually go off into ArcGIS Online and look at it. So I'll just refresh this page, and you will see in my content in ArcGIS Online, I've already logged in. You'll see under the Guelph folder where I saved it, I have two Guelph Trails GPS. I have the file geodatabase, which was uploaded, and I also have the feature layer. So if I pick on the feature layer, you'll see there it is, it's published. There's all sorts of information. It's a polyline layer. You could look at the settings. And you'll see it's enabling editing right here. It's already been allowed. Add, update, delete. That's all been set when I published it. You can always change it after the fact. So I'm just going to minimize this, go back to overview and minimize. So now that it's there, I'm going to remove that SDF from my current drawing. The best way to do it now, if I remove it from my legend, if I right click here and say remove layer, it's actually still, yes, remove it, get rid of the styling. It's actually still attached to my current drawing. To really disconnect from it, you have to go to Map Explorer, find Guelph Trails, and click remove. Now the SDF is disconnected completely from my drawing. So I want to do that. Now the next step, since we've published that SDF and then we detached it, we back into a blank drawing, let's go into the Autodesk connector for ArcGIS. So if I pick on that, I can search by location. I can window an area. And I'll just window around Guelph right there. And I'll go into my content. And the only thing under my content, because I'm logged in, is the Guelph GPS trails. And then I'll just add to my design project. So what I've done is I've logged into ArcGIS Online, picked the area of interest, went to my content, found the Guelph Trails GPS data set, and there it is. It's now available. I can toggle it on and off. And this is streaming live from ArcGIS Online. Now this could be from your ArcGIS Enterprise, your portal, but it doesn't matter. So you've seen that we've taken a file, published it live to ArcGIS Online, and now we've used the Autodesk connector for ArcGIS to bring it in. And there's one more thing we can do. We can actually zoom in and say we wanted to adjust the trail slightly. We can see here it's not quite aligned. So I can actually pick on the grips and move the trail slightly. You can see what I'm doing. I'm moving the trail. And you could do this anywhere. And then once I'm done editing, I can right click on Guelph Trails and say check in features. And what it just did is it actually updated live. ArcGIS Online has been modified. We've done some live edits inside of AutoCAD Map to ArcGIS Online. Now this is an amazing new feature. So the Autodesk connector for ArcGIS is an amazing vector connector. We can add lines, points, polygons, even edit them directly in AutoCAD Map. Next, we're going to add a Web Map Tile Service, or WMTS, to our current DWG. The service is coming from the U.S. Geological Survey map service, and it covers the topographical map of the entire North America. But we're going to zoom into our area right now, Guelph, and look at what the USGS topographical map looks like. When we open up the Guelph DWG, we see that there's a background map. I have the map roads on. Now we can turn on the aerial or flip it back to road, and it just gives us some spatial context of where we are. So you can see Guelph on the map. If I zoom way out, you can see that we're sort of northwest of Buffalo, sort of due west of Toronto, and northeast of Detroit, just to give us some context where we are. So I'm going to zoom back in. And you can see in the outline of the city limits there. Now that's just a P line on the city limits layer. But I'm going to turn off the map road in the background just so we can see a blank map. Next, we're going to click on Data, Connect to Data. And we have 3 open source connections. We have WFS, Web Feature Service, WMS, Web Mapping Service, and I think the most powerful is the Web Mapping Tile Service. The reason this is more powerful is because it's a tiled service, meaning that the data isn't dynamic, but is super fast because it's tiled. It means it's already cut into little sheets of raster imagery that will stream directly to our current map. Now I'm going to just call it WMTS_USGS. And the URL I'm going to use is actually in a text file on our drive. So let's go back to our desktop, and under our exercise files, under chapter 7, 0706. Now we've already got the Guelph DWG open right now. That's the one we're using, but we're going to get the URL from this text file. So I'll just double click on it, open up a notepad, and it's a big long URL. So I'm going to highlight the whole thing right to the .xml. I'm going to copy it, and I'm going to paste it in the server name or URL. Just paste it in right there. You make sure the .xml is on the end. I'm going to leave the version 1.00. I'm going to leave the show proxy settings alone and just click connect. We don't need a username and password for this particular service. Sometimes you do, but in this case we could leave it blank and hit login. Now we have 2 options available to us. We've got the USGS Topo default 28mm or the USGS Topo Google Maps compatible. We're going to pick the first one, the 28mm. And you'll notice that it's in WGS84 Pseudo Mercator. That's the web Mercator that's seen on Google Maps and all sorts of web-based mapping. But our current map down here says our current map coordinate system is in UTM-8317. That's okay. It will reproject on the fly because it knows what the current coordinate system is, and it will reproject those tiles into our current map. Now this does slow it down slightly because it does have to reproject those tiles. So if you want it very, very fast, you would set your DWG to the pseudo Mercator, just like the data coming in. But in this case, I'm not too worried because we're only interested in our city. So let's click Add to Map and then close our data connections. Now what it's trying to do is put all of North America into our UTM Zone 17. So the whole world looks very squishy and warped because we're looking at it in one particular UTM zone. In order to find out where we should be, the first thing I want to do is take our map base in our display manager and drag it above our topo. By doing that, we basically put the red P line that shows the city limits above the topological map. So now if we zoom in, you could see the red outline of where Guelph is on our map. And as we zoom in, we can see things are starting to line up a lot better. That's a lot better now. You can see the topo being redrawn as I zoom in and out of the map. Okay, something else I want to do is just rename this layer. So I'm just going to call it USGS space topo and then get rid of everything else. There we are. So I could toggle it off and on. And although I turned off, I'll go back to the home page. And although I've turned the map off, I could actually turn it back on. I could turn on the aerials, for example, in the background. And you won't see it until I toggle off the topo because it's above it. There we are. You can see the aerials behind and this on top. Now, they don't bring much value if the topo's on, so we can turn it back off again. And as you can see, it's drawing it as we zoom in. Each tile is redrawing. So these are images that are coming on at each zoom level. As I zoom out, different tiles are being drawn and sent across the internet to me from this topo map. So what we've done was use the WMTS Web Mapping Tile Service from the U.S. Geological Survey to draw the tiles in our DWG so we can give a lot of context to our current DWG. Now, we don't have to use USGS. Any service that's available, because WMTS is standard, and that standard can now be applied to any DWG you are using. When adding any vector, points, lines, and polygons based data, you can change it, how it looks with color, fill, symbols, fonts, things like that. Vector-based data coming from databases and files are styled the same, regardless of where they're coming from. So in our current drawing, guelph.dwg found under CH08-0801, we're going to drag and drop the point of interest SDF, POI, and the streets SDF into our current DWG. Now, whenever you drag and drop a new layer or add just a brand new layer, AutoCAD Map assigns a random color and style to your layers. For example, in my particular DWG, the POIs are just brown circles and the streets are kind of a purpley color. Let's fix that. So as soon as I drag and drop the point of interest coming from that SDF file, I get that strange round brown color. So you have two ways of changing this. You can highlight the layer inside the display manager and click on the style button, or you can open the style editor by simply double clicking on that layer. So that's my points of interest. So I want to change this thematic style. So where it says style, we're going to be changing the brown circle. Now you'll notice here it says point style 0 to infinity scale range. That means from 0 to whenever, this is whatever the color is going to be for those scales. So that means it's always going to be that style no matter what scale you're zoomed in. Another lesson will show you how to change the scale ranges for particular layers, but in this case, we're sticking with the 0 to infinity. Where it says style, if I double click on it or click the ... button, so see where it says style point, I can double click on it as well, and I get the style point. There it is. Now we can add a symbol or change the existing symbol. Right now, it's in device units or map units. Now this might be unique for some of you because most people use AutoCAD will always be in map units. Whatever it is you draw them, it's what is going to be in the map. And for those of you who use GIS, such as ArcGIS Pro or QGIS, your data is going to be in millimeters or points and that sort of thing. So it's really nice that we've got this bridge between device units, meaning what it is on the screen, or map units, what it's measured real time on the ground. So if you said that something is 5 feet across, if you were measuring it using the measure tools, that symbol will be 5 feet across. I'm going to leave it in device units, inches for now. Next, I'm going to go into the select symbol and change the style. I'm going to choose star rather than a circle. So now I have a brown star, but I'm going to change it to red. I'm going to make it a red star. Now the edge is black, so I'll make that red as well. So it's going to be a red star throughout. Both the fill and the edge are going to be red. Let's hit apply and close, and you can see in the background now, I'm going to close all my dialog boxes, and you can see stars everywhere where all my points of interest. That reminds me, it says POI in the legend, so I'm going to pick on it and rename it to points of interest. There. Now, it'd be nice if they were labeled. Now, you notice as I zoom in, they stay tiny. They stay relative to the screen, not relative to the map. I may want the star to get really big as I zoom in. In order to do that, I'll go back into my points of interest, and pick on the style. And I'm going to change my units to map units, and I'll say maybe meters on the ground. And I'll make it about 1 meter across. Okay, and hit apply and close. And you'll see the points of interest are tiny now. But if I zoom in, they get bigger as I zoom in. And because on the ground, they're 1 meter across. So if I use the dist tool, D-I-S-T, and measure, say from the point to point, it's about 1 meter across. You can see. So that might be too small because we want it a lot bigger. So let's make it 10 meters across for now. Let's go back in and we'll say it's 10 meters wide. There we go. Apply. In the background, you'll see 10 meter. They're still small when you look at them at this scale, but when you zoom in, they get bigger and bigger and bigger. That's 10 meters. We can keep experimenting, maybe even make them 20. That would look nice. So I'll make them 20 meters across. And I also want to label them. So I'll hit apply and close. And to label a feature, you could go in here to the legend label. Again, you could have map units or size context. I'm going to use the meters. And I'm going to click add label. Now, by default, you could type whatever. And everything gets whatever in there. But what we want to do is change the text content to one of the columns in the SDF name. So if I hit apply, now we're using that. But it's saying the height is only 0.4. So let's make the height 5 meters high. Okay, and hit apply and close. Now if we zoom in, we can see all the labels are about 5 meters high when we zoom in. Well, let's go back in and change the, I'll close out of there. I'll go into the feature label, and 5 meters may not be big enough. I'll make it at least 12, and I'll hit tab and then apply. And you can see it's a lot bigger in the background. Let's zoom in the background. Yeah, that looks a lot better. And I could do other things like I can change the font from Arial to Arial Black, for example. I can make it bold. I can change the text color. I can hit the bold button like that or not, make it italic, underline, and so on. Your alignment can be anywhere. It could be offset by a particular number of paces. You can make it glowy, ghost color, so you can make sort of a blank halo around it. And what's good about the halo is that if you were to turn on, let's go back into home, I'll turn the map hybrid on. So I went to my home ribbon, turned on my map hybrid, and that way you could see that when I labeled my points of interest, you can see the halo is actually making it much easier to see with an aerial photo in the background. And that's a really useful tool to use that halo. So I'll go back into my feature label, and it's this ghosted color. It puts a halo around it, a ghosted color. I can change the background color so it's a solid block, and I can put a frame around it. But right now they're blank. But I have put a white ghosted color around it so it's easier to see. I can also rotate it. Also, if I have rotation in the database or in the file itself, I could actually derive the rotation based on that. Okay, let's close that up. So that looks pretty good. We've made a fixed point of interest that zoom in as you get in farther, and as you zoom out, gets smaller. Maybe hard to see at this scale, but it depends on how you're plotting your map. I can totally override that and go back to the map units. So I can go in here and say go to millimeters on the ground or points, and I'll make it say, a 10-point size. That's good. Close that. And I'll make the feature label, I'll make it 12 points. Did you notice that the device points inherit whatever the style of the point is? So if you see that, because I changed the style of the symbol, the style label is along for the ride. So therefore, if you change the unit style to map units or back to device units, that will happen inside the label itself. So keep an eye on that. That's why all the symbols disappeared. They're just too tiny. Now if I hit apply, now you can see it. Now when I zoom out, they're quite big. That might be too big. So again, it's all about style and preference, and maybe 12 points. Maybe I'll go to 8. That might be much more readable. There we are. And there we are. So I've used device units, and then I went back to using number of points on the map. So it's actually an 8-point font with a 12-point symbol. Well, we could do the same for line work and polygons as well. You can go in and change the style. So I'll go into the style of the line, and I'll make it a black color. Apply. Now, the solid black line is kind of hard to see with aerials. So what we could do is give it a sort of a halo as well and a bit thicker line. So let's go back in, and maybe we'll make the one thickness a little wider. And you'll notice on the curves, we can bevel it or round it or none. So it's a very sharp or miter it, but by default, it's rounded on the edges. And then when it comes to an end, it rounds it, or it could be blocked around the ends. And this really shows up when you make the thickness of the line really fat. So right now it's not that fat at all, but as you adjust it, you can change that. Now we can combine symbols to make this look quite interesting. So if I click add symbol, and now I have a different line, I could say a solid line that may be a little thicker and maybe with a white background. And then you've got sort of a halo around all your streets. So now you could see all the streets show up very well with an aerial on the background. But if I turn off the hybrid, they're still very visible. All the streets are very visible. But if I turn on the aerial again, that halo that I created remember, what I did was I went in and I have two symbols. On top, I have a black line, and underneath, I have a white line that's a little bit thicker so that it pops out. You can see that. So now we've got two different styles. So I'll close that up. And the same is true with polygons. I can change the fill and the edges just like I'm doing with the points of interest and the streets. And you have this ability to completely change the vector data. Now remember, this isn't affecting any of the data in the background. The SDF or shapefile or whatever is not being affected in any way. This is only how it's viewed in this particular Guelph DWG. And those styles are saved in the drawing, not in any kind of file other than the DWG. So you've learned that your maps can look great with all the style tools available for vector-based GIS data. Color coding your GIS vector data based on an attribute in the data is called a thematic layer. Thematic layers can be based on points, lines, or polygons. Typically, a theme might include the color coding of your parcels based on zoning. That's exactly what we're going to do. Let's open up the DWG found under Exercise Files, Chapter 8, 0802, and then we're going to drag and drop the zoning SDF into it. Now, the default color or style is always assigned as soon as you drag and drop something into your new DWG. In this case, it's almost a mustardy yellow color. But what I want to do is color code each individual parcel based on some data. Now, if I zoom in and I pick on a particular parcel, I right click and look at the properties in the property pane, you can see it has a zone 1 designation. It's those zone 1 designations. I could do this as well by clicking on zoning table, and we could look at all the data inside of there. There we are. I could sort by zone up and down. And you can see a lot have null and they have various. So let's use that as a way to color code these parcels. So highlight the zoning, click the style button or double click on zoning. And we're going to click the new theme. So we can manually click a rule or generate a theme based on the values in the database. So I'll hit new theme. And it says, what property do you want to use to derive everything? I'm going to use the zone. And it'll give me a range from the minimum value to the maximum value, basically just the range. There are individual values in the distribution. It looks like there's 460 types. And the range can be from one to the other. So you can actually go in and sort of pick the range from the maximum to the minimum. So here's all the different colors. So you can say this one starts here. And we can change it to like a really light color, maybe in the more colors here, and I could say maybe even a lighter yellow. And then this one could go to more of a reddish color. Perhaps I can make it pinker. There we go. Hit OK. And I'll just hit OK. I'm going to leave all the rest. So what we're doing is we're leaving the symbol of the edge the same, but the inside fill is going to change. And I'm not going to even affect the transparency. So let's click OK and OK. And we saw there's so many different rules in here. So it takes a while. And you'll see that your legend, I'll close this dialog box. You can see here's all the different colors. From pale yellow being the 1.2-1 zoning designation, all the way to like a pinky color near the end, 600 more down the road. You can see there's so many within our legend. They go on and on and on. Look at them all. There's so many. So this is too much. There's far too many ranges here. Normally a 9 or 7, maybe that should be the maximum number of categories you should have in a thematic map, because the human eye can't really distinguish that much to really figure out what's what. So I'm going to go back into that layer and I'm going to create a new theme based on the zone. But this time I'm actually not going to use the theme layer. I'm going to delete all. Yes. And I'm going to create a new rule myself. So I'll say add a rule, and the first one will be where the property, this is really nice. So what I can do is in the thematic rule, I can hit the ... button, and it opens up this expression builder. The expression builder is very powerful, especially for building logic for inside of our data. So I'm just going to close that wizard. And the first thing I need to do is what property am I going to be filtering? So in the drop-down box, this gives me all the different types I have. I have text properties, numeric properties, geometric properties. In this case, it's text. So I say zone 1 equals, and then I can get values, and it'll actually run off and give me all the zone, all the hundreds and hundreds of them. But what I want instead is I want all the stuff that begins with I for industrial. So I'll do that. So what I've done is I put a single quote, a capital I, a %, and another quote. So I'm saying where zone 1 equals, equals won't work here. I need to use a different operator. The operator I need is like. There's also a like right here. I could insert like or equals. I don't want zone 1 equals to something. I want zone 1 begins with an I. So I have zone 1 like I %. So this will filter out all that sort of stuff. So now if I say anything with an I will be that gray color, and there we are. So we've got that going in here. So only, if you see in the background, it's refreshed, only those parcels that begin with I, only the industrial will be that gray color. And I can change that. I should change the legend label so it shows up in my theme, and I'll say industrial. There we go. So let's do the next one. We'll add a new rule and we'll filter it. Let's pick on the first one and we'll say zone 1 like, and we're going to put in C, capital C, %. Now the thing is, it needs to be in single quote. So one little quote there at the beginning in front of the C, a capital C and a %, and a one little quote afterwards. So it'll say zone 1 like, single quote, C, %, single quote. And if you're ever curious how that's going to work, just hit the validate button at the bottom. It says the expression is valid. So for example, if I forgot a quote and I delete it and I hit validate, it says expression is missing a closing string character, which means a single quote right here. And we're good to go. Validate. Great. Okay, so let's click OK. And that's commercial. Oh, I don't like the gray color. So let's change this and make our commercial. I'll leave the edges the same, but I'll make the commercial color maybe a sort of orangey color like that. Okay. I can even play with the transparency. Maybe I'll make it 50% transparent. Let's hit apply and close. Which reminds me, I should label this too. Commercial. There we are. Now that gray color, I should make that 50% transparent as well. Now, you notice that the edge isn't transparent, it's the fill. So I went into the gray style of industrial. I've highlighted the fill color, and down here it says transparency. I'm going to say 50% transparent. Hit enter and apply and close. So now not only is my industrial a gray, semi-transparent, my commercial is sort of this peachy color, semi-transparent. The default color is still there, but I'm going to add another classification. So let's hit add a rule. We'll double click on the first one. The property is zone 1, like. Now we're going to try residential. We'll say R %. Let's validate that. Yes, anything that begins with R is a residential. Let's hit OK. And we'll change the color to more of a, let's pick on the symbols. Let's pick a different color. Maybe this one will be more of a purpley color, like that. We'll make it 50% transparent. Apply and close. And we'll say residential. There we go. And that purpley color is too close to industrial, so maybe we'll change that a little bit. Maybe make it more of a greenier color, or they're purpley. That's a little better. There we go. And 50%. Maybe make it 75% transparent. That looks nice. Okay. So you can see we've got industrial, commercial, residential, and there we are. Now what's left? So if we go in our table and look at all the different types, we've got I zones, C zones, we have nothing, residential, commercial. Look at all that. We have special, wetlands, things like that. So we'll leave the rest blank white. So let's go into the default and set the fill to be no color. Apply. So you could actually make it no color, so there's no fill at all. Let's close that. So now you can see the areas without any kind of designation, industrial, commercial, residential, in the background as a clear fill. And if you want to see what that is, we can pick on it and look at the properties. There you go, it's B, business. So it's deemed business, it's a different category. So maybe we want a business one. So let's go back in. We'll add a new rule. This one will be name one, like B. Okay, we'll call it business. And we'll change this color. Maybe more yellow. There we are. Change it to say 25. Transparency. There we go. No, 50 does better. So you can experiment with your colors and so on. So now we have industrial, commercial, residential, and business classifications. And everything else is clear. And you can toggle this on and off whenever you want. And it'll redraw it from the database, as you can see. And the best part about this is that this layer doesn't affect the original GIS data. It's using the GIS data to draw something, but it's not actually modifying the original data. The style is stored in this Guelph DWG, not in the file. So you can paint this any color you wish. So representing data attributes in a graphical way makes thematic layers very effective in communicating more about your data. Since most GIS data has attributes, you can create a thematic map with most of your GIS vector layers. Sometimes your data is far too large to display at all scales. For example, you would not want to display every single tree planted at the national scale. Adding scale dependence can limit the scale where that layer will appear. You can also change the style of that layer at various scales. Let's do that now. I'm going to add the parcels STF in exercise files CH08 0803 to my Guelph DWG found in that same folder. So I'll drag and drop it into that DWG. And there's my parcels. They come on at all scales and they have the default color assigned. First thing I want to do is have them turned off at about 125,000 scale. You know what scale you're at. By looking down at the middle of your AutoCAD, you can see what your particular scale is. You could even set it to a particular scale. So for example, if I go 125,000 and click OK, the scale is currently at 1 to 25,000. That is where I want these to turn off. That's the scale at which I want to cap the parcels. So if I double click on parcels and change my scale range from 0 to 125,000 and close this, you'll notice as soon as I zoom out past 120,000 and I zoom back in, it kicks in, zoom out, it's gone, in, they turn back on again. So you could have it so that you could really improve performance of how your map reacts by having parcels only draw at particular scales. Now I may want it to be hollow at this scale because it's quite busy all filled in. So what I'm going to do is I'm going to go into the parcels and say from, let's make 30,000 scale to 125, I'm going to make that a transparent. So I'm going to get rid of the fill. I'll just remove the fill. So it's just an empty black box. And there you go. So once I zoom in past 30,000, they should disappear because I still don't have a scale range for that. So let's add a new scale range now. So I'm going to add a scale range from 0 to 30,000. And this 0 to 30,000 will definitely have a fill. So I'll add a fill. And I'm going to make it sort of a nicer color, maybe a light beige. There we are. And I'll make the edges not so black. I'll make them more of a gray color and apply that. And now I'll close my style. So there we go. So when we zoom in, we go from a dark, hollow parcels to a lighter beige color. And you can see as I roll out past 125, they completely disappear. Let's look at why that is. So from 0 to 30,000, I have that beige, peachy color. And from 30,000 to 125,000, I have a hollow parcel. And that dark black may be too dark, so I'm going to actually change the edge color to that lighter gray as well. There we go. So let's look. So we're going to zoom in past 125 threshold. There's the parcels, and they're just that light gray color. And as I zoom in, they keep the edge, but now they're a peachy color. But what if I want to label them when you zoom in really close? Let's do a third zoom scale. So now I'll go in here, I'll add another scale. Right here, I'll go add scale range. And this time I'm going to cap the other one from 2,500 to 30,000 and take this one from 25,000 to 0. So our ranges will be 0 to 2,500, 2,500 to 30,000, and 30,000 to 125,000. And after that, you won't see anything. So the only difference so far between 0 and 2,500 and 2,500 and 30,000 is just that they're in different scale ranges, but nothing's changing. What I'd like to do at this scale is change the label because none of these layers have a label. But this time I want to add a label, and we'll use the map scale. We'll use it in meters on the ground. We'll say add a label, and we're not going to use static text. Maybe we'll put the object ID in there. So it labels the parcel ID, so that's what the object ID is. And we're going to set the scale to say maybe 2 meters high. There we go. Hit apply, close, and let's zoom in and see what that looks like. So zoom in, zoom in. Once I hit the 2,500 mark, there we are. And maybe 2 meters is too small for these parcels. So maybe make it more like 20 meters high. So let's go in, 0 to 2,500, feature label. It should be in meters. We said it was, oh, still not right. So meters, we'll make it say 2 meters again. Apply. There we go. And you can see in the background, that's not bad. So maybe I'll make it 3 meters high. Apply. That's pretty good. So those are the parcel IDs. So now you can see that as I zoom out around, that looks pretty good at 2 meters for all these parcels. If I zoom past 2,500, they should all disappear. But as soon as I zoom in, there they are. And you can adjust heights so that they fit better. You can see that some of them don't fit perfectly, so they may need a little bit adjustment, but that's pretty good. And as I zoom out, the numbers disappear. I keep zooming, it drops the color, and when I zoom out to this scale, everything's gone. So now that you've learned how to control the visibility and the style based on the scale, it's always a good technique to review all your largest data sets to see which should be limited by scale to improve the performance of your maps. Showing the subset of the GIS vector data using filters can quickly limit the data you wish to see and cut out those records you don't need. For example, if you only wanted to see the roads within a particular country, you could filter the layer based on the country name. Or we could filter geographically. In this drawing, we're going to filter the zoning SDF within the guelph.dwg file. So rather than dragging and dropping the zoning SDF, instead I'm going back to the task pane, picking data, connected data, choose add SDF connection. I'm going to call this SDF zoning. I'm going to choose the source file, that same SDF we just saw under 0804 zoning. Hit connect. And now we can choose in the drop-down box, add to map or add to map with query. If we choose add to map with query, we get a lot more options on how to filter the data we want to look at. For example, if I choose add to map with query, I can now create a query based on some attributes of the SDF file or columns within it, or I could use the locate on map, which is very powerful. I'm going to choose locate on map, polygon. Now I can draw, and I'll just create, and I'll just draw a quick little polygon of the parcels I want to bring in. When you're done, just press enter. And I hit OK. And now it'll only draw the polygons that intersect or inside that polygon I just drew. Now I can close my Data Connect window, and I can right click on the zoning layer and say query to filter data. I can clear this polygon and draw another one by going locate on map, and I'll say rectangle, and I'll just draw a rectangle inside of there and click OK. And now it will draw inside that particular rectangle. What if I wanted two separate areas? So I can go back and right click on zoning, query to filter data, and I'm going to use the or command. So I have inside that polygon I drew before, or I'm going to draw a circle, and I'll say create, and I'll just draw a circle right here. So I'll say inside that one polygon or inside that other polygon, that circle. I'll click OK. And now it's going to do a subset of those two areas of my overall SDF. So it's filtered out geographically those two zones. Okay, let's go back into zoning. We'll go back into query to filter data and clear our query. So the nice thing is I can always modify the query after the data is attached. So I don't have to keep going back to the Data Connect window and add to map with query. So in this case, I'm actually going to just completely clear everything and hit OK. So I have all my zoning drawn. So there's no filter whatsoever. Let's go back into there and go into query to filter data. And this time I'm going to take where the zone is like I %. So I'll validate that, make sure I've typed it right. Yes, so it's I % in single quotes. So that's industrial. So I'm going to change the name to industrial. Industrial. And there we go. Now, what if I wanted to add commercial? So I could add a new layer, or simply I could right click on that layer and I could say copy and then right click and paste. And that way I have two industrial layers. But instead, I'll right click on there and say query to filter data. Instead of the I, I'm just going to edit that and just go C. Make sure it's correct. Yes, it is. So zone 1 like C. And that's commercial. There we are. And I should change the color I'll just make it a different color to maybe green. There we go. There's my style. I'll move that up above industrial. So look, we have commercial that I can toggle on and off, and industrial if you toggle on and off. If we made a thematic map, we wouldn't be able to toggle off individual types filtering this data. We'd have to turn off everything and then turn them all back on. Now we can break it out. Let's do one more. Let's do residential. So I'll copy and then paste. There we go. Let's move the industrial up. We'll rename that to residential. We'll right click on it and go query to filter data and put R in there instead. So zone 1 like R in single quotes with a % sign. Let's validate it. Yes, it's valid. Hit OK. So residential. Oh, but it's the wrong color. So let's double click on that and make residential sort of a beige color. So go in here, change the fill to this beige color, hit apply, and close. So look at that. Now we've got industrial, commercial, and residential all broken out that I can toggle based on some attribute. Whereas before you saw we can filter based on geographic location, and now we're filtering based on attribute, getting a subset of the data. We could do either or combine them. Filtering can be done before the layer is even added to AutoCAD Map 3D or after the layer has already been added using the query to filter data. The first technique may reduce large data sets before they even arrive inside of AutoCAD Map 3D, and that would save time when rendering in the map. Raster images cannot be styled, but raster surfaces can. Raster surfaces can be color-coded based on the elevation, slope, or aspect. Next, you use a pre-canned palette based on the USGS, US Geological Survey, color palette. We're going to add the guelpheast.dem file to our current Guelph DWG under 0805 folder. So in our task pane, choose Data, Connect to Data, pick on Raster Image. We'll just call the connection name DEM. We're going to browse to a single file. So we'll hit Browse, go into CH08, 0805, and pick on the guelpheast.dem. Click Connect. We'll just click Add to Map and close the Data Connect window. So you can see the Guelph East DEM is several tones of green representing elevation, and you can see in 2 dimensions a little bit of how the elevation is affected within this part of Guelph. So let's change this so it looks a lot better. We can style this layer, so let's double click on Guelph East. In the drop-down box called Style under Raster Style 0 to Infinity, let's choose Theme again. You'll see Theme, Full Color, and Grayscale, but we're going to choose Theme again. This will trigger the Theme dialog box. We're going to theme based on the height, so that's not going to change. We could choose slope or aspect, but we're not. We're going to just leave it as height. And where's this style ramp? We're going to flip that to palette. And there's a series of pre-canned palettes that come with AutoCAD Map. This one we're going to use the USGS National Map palette. So let's pick on that one and click OK and apply. We're going to close the style editor. Now let's zoom out and look at this new palette. Now you can see some of the lower elevations, which are 303 meters high, as you can see in the legend, are a dark green, and that's in the river valleys. And if you scroll down, you can see the highest elevations, which is 449 meters above sea level, are in that light white at the top of the screen. So now we could take this DEM and generate line work or contour layer. So right click on Guelph East and click Create Contour Layer. We're going to leave the contour name as Guelph East _contour. That's fine. The contour intervals will be 1 meter Every 1 meter will get a contour line, but we're going to make the major contours every 10. So we'll get one thick line every 10 meters. We have a choice. We can save it as a polyline or a polygon. So each layer is a polyline or could be a fill. But in this case, we just want traditional polylines. And let's click OK. Okay, there's the Guelph East contours. I'm going to turn off the DEM in the background. And I'm going to zoom in tighter to these contours. Now, because we're working with a DEM that is 1 meter intervals, you're not going to get as smooth a contours you would as a higher density, maybe a LiDAR based image, but this still gives you some basic elevations. If you notice, if I pick on one of these elevation lines and hit properties, you'll see that, is it a major line? No. What's the current elevation? 339. And there's an index, so 339 in that case. We can look at all of them. If I highlight Guelph East contour and hit table, you can see all the various elevations. There we go. We'll zoom out. You see there's our contour data. Again, it's not that smooth because the contour lines were generated with 1 meter intervals using a DEM. You can get smoother data using LiDAR. Okay, so you've learned how to color code a DEM based on the USGS palette and how to create a contour line based on the same DEM file. Adding additional data to vector-based GIS data can be done using existing AutoCAD-based graphics. Simply selecting each AutoCAD object one at a time and adding attributes after each selection is performed in this lesson. So first we're going to open the Guelph DWG under Chapter 9, 0901, and we're going to drag and drop the Streets SDF into that current session. We're going to add 2 brand new streets. These 2 streets are actually AutoCAD objects. So if I select on it and you look at the properties, you can see it's just a polyline in AutoCAD, has nothing to do with the Streets SDF file or any sort of GIS connection. It's a plain old polyline. It's on the Streets layer. It has object data attached. It actually has Gordon Street attached to it. The other one, if you pick on it and look at the properties, you'll see that it has object data as well. It has Southgate Drive. How do we add this data to the existing Streets layer? I'm going to change the color of Streets just so it's more obvious. I'll change it to red just for now because I'm having trouble seeing it with this monitor. Let's do that. There we go. We changed it to red. Ah, it's much better. Okay, so let's add this Gordon Drive road right here. It's a P line drawn in AutoCAD on a regular AutoCAD layer, but we want to move it to this Streets layer that I can toggle on and off. So the quickest way to do that is right click on Streets and choose New Feature from Geometry. That's going to ask me to select a feature in AutoCAD, an AutoCAD object that will be converted into an FDO object or a GIS object. Let's pick on that new Gordon Street line and press enter. Do I want to erase the original AutoCAD object? Yes. That object disappears, creates a new line inside the Streets. It's prompting me to edit data. Now you'll notice the feature ID or feed ID is grayed out because that's an auto number. I don't have to worry about typing anything there. It will automatically enter. What I do need to enter is this street name, which is Gordon Street. Now you notice this had object data. It didn't inherit any of that object data. So here's the trick when dealing with this. I'm just going to hit enter. It does not absorb object data or link template data. So you've gone through all that work of adding object data to your lines. So this technique is not for that. So remember, when you right click on the layer and use New Feature from Geometry, it does not inherit the object data. Let's just check that in. See that pencil next to the Gordon Street there? That will disappear once I check this in. So I'll right click, check in features. Done. The pencil disappears. That line will zoom and highlight. There it is, Gordon Street. Okay, let's close that up. Hit escape. We want to do the second layer. So let's pick on that. Look at the properties. Again, it's a polyline. It has object data. Actually, I'm going to copy that before I do anything else. I'm going to go copy, because guess what? It's not going to inherit this object data. So I might as well copy and paste it right now. So let's do that. So this, you got to be careful. So let's right click, new feature from geometry. So I'm going to pick on that AutoCAD object that has object data, press enter, erase it, sure. And now I'm going to paste from that properties pane. I'll just paste it in. There we go. Southgate Drive. Press enter. And to make this permanent, I have to right click on the layer again and go check in. So now that pencil disappeared. If I highlight it, there it is. That segment is appearing. So the two new lines is the Southgate Drive here and the Gordon Street here are now part of the streets layer. It's erased the two lines that were already there. And now we have data inside the SDF file. So existing AutoCAD objects may have object data or link template data, but using this particular technique does not harvest that data. You have to manually add the attributes after selecting each object on the map. In another lesson, we'll learn how to harvest that data. Keeping intelligence such as object data and link template information when moving data into vector-based GIS data is critical for data integrity. You will load multiple objects into a GIS dataset in this lesson. So let's do that now. In the Guelph DWG file, located under Chapter 9, 0902, we're going to drag and drop the parcels SDF into it. Now under View, here, you'll see that there's a name view called New Subdivision. It will zoom into the area of the city. I'll zoom out just to show you where that is, where there is some data already existing. The green data, I'll go to Home tab just to show you. If I click on that, you'll see that's on a parcels layer in AutoCAD. These are P lines. If I right click on it, look at it, it's actually a closed P line. See, closed, yes. And it has object data, has an ID, it has a street name and a street number. So that particular parcel is a closed P line in AutoCAD. It's not part of these parcels right here that I can toggle on and off. I want to export these into that SDF file. So to do that, we have to go to Output, DWG to SDF. We'll pick on the SDF on our exercise files, Chapter 9, 02. We'll pick on the parcels. That's the one that we have currently attached. We'll pick OK. And we're going to append. Do not overwrite, because that'll erase all my original parcels. I'm just going to append this half dozen or so to the current database. So hit append, and we'll select everything on the parcels layer. We'll hit feature class, and the feature class already shows it's the parcels feature class. They're polygons. We have to pick the right attributes, and those are the object data. So make sure we have the ID, street name, and street number. They already existed there. We'll hit OK. So now we have attributes that are those object data are going to go across. As well, it's already found the parcels feature class that knows they're polygons. And one thing we have to be very clear of is that we treat closed polylines, which these are, as polygons. If we don't do that, we won't be able to export them. So by saying the closed polylines are polygons, we could push all these parcels into the parcel SDF file. Let's go ahead and try that. All 27 were exported, but they don't show up yet. So if I right click in my display manager, I choose update, there they are. It queried all the new parcels in, all 27 of them. If I pick on one and I right click and look at properties, you can see, yes, the ID came across, the street name came across, and the street number came across. So I've got all the data that had object data attached over to this by using that one tool there called DWG to SDF. Now, if I try to do it manually by using the new feature from geometry, as you know, that will not absorb the object data or link template data. I'd have to type it all back in. As well, I'd have to do each individual parcel one at a time. So unlike exporting, loading AutoCAD objects into GIS vector data such as SDF appends the data to the existing GIS. This way, the AutoCAD objects and associated attributes are transferred directly into the existing GIS data and not lost. Adding GIS vector data to your map allows you to edit and create new features. Adding new features from scratch or drawing directly on the screen is available for all GIS vector layers, regardless of type. Let's try that now. In the Guelph DWG found under Chapter 90903, we're going to add the points of interest. Let's drag and drop that in now. There's the points of interest. Under View, we're going to zoom to an area where we're going to draw a brand new point of interest. It's called Top Guelph. Let's pick on that. It'll zoom in. And I'll zoom out a little bit so you can see what I just did. I zoomed into the top corner of Guelph right there. And we're going to manually add a brand new feature. So how we do that is, and the point of interest layer, POI, we can rename that to point of interest if we wish. Point of interest. There we go. And we can right click on it and choose Create. Now the Create button is different than the New Feature from Geometry. New Feature from Geometry expects an existing AutoCAD object. It could be a block, it could be a point, whatever you want, a P-line. Whereas Create makes you draw from scratch. There's no existing features on the map that we're working with. We're going to create it brand new and digitize it on the screen. For this particular layer, the point of interest, it's asking for a new point for this point of interest data or a new multi-point point of interest. The difference is a point is a single dot with attributes attached to it, whereas a multi-point, you can draw multiple points or multiple dots, but the attribute data is attached to all the ones you just drew. So the powerful part about that is you can have multiple points with all the same attributes attached to it. So it could be a string of islands, for example. In this case, we're just going to create one single point, new point POI. And you can see it wants to put me into draw mode. So what I'm going to do is I'm going to draw to the very tip of this intersection right there, endpoint, and click right there. And now we have a new editable area. You'll see that the feature ID is grayed out because that's going to be auto number, so we don't have to worry about that. But the name is going to be required because otherwise it's just a point of interest with no name. So I'm going to type Guelph Dam, space dam. There we go, Guelph Dam. And you'll see that there's a pencil next to it, and it'll stay that way until I check it in. So if I right click on point of interest and say check in features, it is now part of the system. It's item number 38. And I can pick on any of these other ones, University of Guelph, for example, and Guelph Dam. Let's zoom out. You can see everything. Now, if I were to label this, you could really see that the Guelph Dam has been added. So I'll just hit escape. Let's right click and go edit style. Now I could double click on it and we're going to do a feature label. So we'll go in here. We'll choose device units and we'll say points, add label, and we'll choose use the name. And let's say 10 points. Hit apply, close, and close. And sure enough, that's a little, 10 points is a little big. So let's go back in here. Let's make it more like, oops, wrong size. Go into the feature label. Oh, 10 points. Yeah, we want 10 points. There we go. And hit apply and close. There we are, 10 points. So there's the Guelph Dam that we just added. And if you want to add another one, you just right click, create new point, put a spot out here, and I'll say, this is my house. There we go. And it says, we'll check it in, and that text will become my house as soon as I check it in. So check in features, there it is. My house appears. And you can always delete it if you don't want to. So I can go on there, delete. I can delete the Guelph Dam we just added. Delete. And see, they're grayed out, but it's not checked in until I right click, check in features, and they're gone. So as you can see, I can easily right click and create new points whenever I want. And this is true for any vector-based layer. You could see create a new line or multi-line, new area or multi-area, but you have the ability with this particular layer. This is the SDF, but it could be a shape file. It could be a file geodatabase, doesn't matter. You can always add data this way. So drafting directly into vector-based GIS data is an effective tool for maintaining this data. You do not need to have GIS software. It doesn't matter if the data came from ArcMap or ArcGIS Pro or QGIS. Within AutoCAD Map, you can edit that data created by the GIS. So even if you have a shapefile, you can edit it inside of AutoCAD Map. Moving data from one GIS vector data source to another GIS vector data source is completed using the bulk copy tool. Bulk copy enables you to select the features and any fields you want to copy over to the destination. Let's do that now. I've opened Guelph DWG under Chapter 9, 0904, and I'm going to drag and drop both the parcels and a new subdivision into my current DWG. Now you'll see if I zoom to the subdivision, I'm going to right click on subdivision and I'm going to zoom to extents. There we are. So we can see our new subdivision on the western side of the city. And what I want to do, I'm going to take this layer, subdivision, and load it into the main layer, parcels. So that layer, parcels. So the data set will be the enterprise one is the parcels one, and the delivery, maybe from a contractor, is the subdivision. So how do we take the original file and fill it up with the recent file and all the updates? Well, we can use a tool called bulk copy. So if you look under data, we choose bulk copy. There's a number of ways getting to that. So that's inside of the display manager. But if you're inside of Map Explorer, you can go tools, bulk copy. Or again, inside of display manager, go data, bulk copy. So we want to go from and to. So this bulk copy dialog box is split in half. On the left side is all the source data, and on the right side is all the destination data. So first, let's choose the source, meaning the subdivision. So the subdivision, I'm going to pick that layer, and we're going to check it. This is the data we're going to be copying over. And then the target is the parcels. This is where we're going to load data into. So I'm going to pick parcels. And we got to make sure everything matches. So the first thing I'm going to do is schema. That's correct. That's the group it's in. And the name of the layer is not subdivision. What we want is parcels. That's really critical right here. This one little drop down, I have to make sure I'm choosing parcels. Now, the one thing I'm not going to copy over is the feet ID. That's an auto number. I don't want to take the auto number from the subdivision and put it into the auto number of the parcel. So I'm going to uncheck feature ID. Now you can see that the ID from subdivision is going to be in the ID in parcels. Let's just make sure by picking the tiny little drop down that there is an ID. Yes, there is. There it is. Okay. And there's street name. Let's make sure there's a street name in the destination. Yes, there is street name. And a street no. Yes, there's a street no. And is the name of the geometry the same in both? Geom? Yes, geom. So we've lined up column by column all the items. Now you have to do this manually. Make sure that the source subdivision goes into the destination parcels. And you have to make sure you do that. I usually skip the feed ID. This is typical on SDFs or anything like that. And I go ID, street name, street no, geom. Everything looks good. It's going from the source coordinate system is WGS 84, pseudo Mercator. Destination's the same, so I don't have to worry about any coordinate system errors or anything like that. I don't have to worry about unmatched geometric types, so that should work. So we're going to go copy now. Now, before I do that, I can save this profile. So all this stuff is all matching. So if I get these subdivision files from this person a lot, I can save this, and I'll just put it on my desktop as a load subdivision XML. So I can always load it anytime I do this. So rather than worrying about setting all these things up, I can hit load, grab that load subdivision XML, and it'll remember all these checkboxes and things like that. So that's very handy if you're going to be repeatedly loading a new subdivision. Okay, so I'm going to hit copy now, continue bulk copy, and it copied all the 363 brand new objects. And it says, yes, they copied over, they were inserted. It didn't take very long, less than a second. And I click OK. Now here's something very, very critical. If I were to hit copy now again, it would duplicate that subdivision. I'd have another series of subdivisions, all these parcels stacked on top of the old ones. And every time I hit copy now, I would do that over and over again. So bulk copy is really to add new features to your existing enterprise, not update features. This is really a brand new feature. It'll treat everything as brand new. So if you've got old parcels that actually match exactly what you're putting in the subdivision, you're going to get duplicates. So be very, very careful. So hit copy now once and once only. And remember, this bulk copy is only for brand new features and not for features that need to be updated in any way. So be careful with that. So let's close it. Let's not hit copy again because it will make a duplicate, and hit close. Now, if I turn off the subdivision, there should be parcels underneath, and there they are. So what's happened is it's actually bulk copied all those features. And if I zoom in and select on one of them and I hit properties, sure enough, you've got the ID of the street. We don't have to worry about feature ID because that's an auto number. And we see 7 Merganser Drive, and there it is. That's what's brand new. That's been loaded using the bulk copy. That's a very powerful tool, that bulk copy. Again, you could use it 2 different ways, through Data Bulk Copy or through Map Explorer Tools Bulk Copy. But either way, it allows you to get data from a smaller, like the subdivision, to your enterprise vector layer. So we had a chance to bulk copy GIS data from one vector-based GIS to another. And although we focused on the file-based data, the SDFs, some GIS data can be stored in a database, such as SQL Server or Oracle. The bulk copy process is identical for both database GISs as it is for vector. Connecting a database to AutoCAD features is completed with link templates. But for GIS vector data, creating a join to another data source is done with a GIS join. We're going to learn how to connect an ODBC database to an SDF. The SDF will be called Parcels Join SDF, found in Chapter 10, 10.01 folder. In the Guelph DWG, we're going to drag and drop the parcel join into the current session. The zoning join is going to be attached using ODBC. So let's drag and drop that SDF. There's all the parcels. If we look at them, let's pick on one, look at the properties. Now we're going to join based on an ID. So each property has an ID. We're going to use that as a join key. So remember that inside this SDF file, there's a parcel layer with IDs in it. Okay, next thing we want to do is go to the ODBC. And so we'll type search at the bottom, ODBC. We'll open up the ODBC data sources. Make sure it's 64-bit. Click open. Click add under user DSN. Make sure you're using Microsoft Access Driver MDB ACCDB. Click finish. And we'll just call this parcel join underscore join. And we'll browse and we'll look at your C drive under users, find your username, then find your desktop, exercise files. It's chapter 10 and 10.01. And there's the zoning underscore join.mdb. Click OK. So there's zoning underscore join in the 10.01 folder. We'll call it parcel join, hit OK. And now parcel join is listed under the user DSN on your ODBC data source. Let's click OK. Now we need to connect AutoCAD Map to that ODBC connection. So under data, we'll click data, connect to data. We'll pick on add ODBC connection. We'll just call it ODBC parcels. We're going to browse to the data source that we want. And there it is. Parcel underscore join is the one we just created. Pick that and hit test. And you don't need a username and password because this is Access. It doesn't have a username and password. And down below, you'll see the only table in there. It's called zoning. The identity is ID. That's correct. And there's no X, Y, Z, or Z. So we're not going to be adding any geometry to this. We're just making a connection to this table. Click connect. We don't need to add to map because there's nothing to add to map. So at this point, I can close the data connect dialog box. So if you want to see that connected, if you pick on Map Explorer, you can see that ODBC parcels is listed here. FDO, that's the data type we're connecting to. Zoning. We can even open up the table and look at that. There's all the zoning. So we can see that in that zoning table in the ODBC parcels, there's a parcel ID and zoning. That's it. So I'll close that. And you also see parcels join. That's the parcels SDF file we're looking at right now. So let's go back to Display Manager. So we have a table connected to our session. We have the parcels. Now let's join them together. To do that, we right click on parcels and then we say create a join. So this will pop up a create a join dialog box. So the parcel join is on the left hand side, and on the right hand side, let's go pick the FDO zoning table. So there's under the ODBC parcels, we're going to pick zoning. So then we have to choose the columns that'll match. So for the parcels, the SDF, there's a column in there called ID that we're going to use. And on the ODBC parcels, there's also an ID, but in this case, we're going to join on parcel ID. So we'll connect ID to parcel ID. And we're going to keep all the records on the left. So show all the parcels, even if they don't have a zoning. If you only want ones with match, you say keep only the left side records with a match, left being the parcels themselves. So it'll hide all the parcels without a join. Sometimes you'd want to do that, but in this case, I'm going to say keep all the parcels even if they don't have any joins. And we have two types of relationships, a one-to-one relationship or a one-to-many relationship. A one-to-one means there's one record in the zoning table that matches the parcel and show it. And that's all we have to worry about. If there happens to be any more records in the zoning table that match, we're not going to see them. I'm going to grab the first one. It's one to many. We grab a parcel, and if it happens to connect to 3 different records, it'll actually draw that parcel 3 times right on top of each other. So we're going to stick with one to one. Okay, let's click OK. Once it completes, we can see any of the joined data. So we can do that simply by picking on parcels, picking on table, and you'll see that the parcel ID should match the ID inside the main table. The table is connected to in the join will have zoning and then a little pipe sign. So you'll see zoning pipe ID, zoning pipe parcel ID, and zoning pipe zoning. So therefore, what we started with was a parcel, like for example, this one here, Valley Ridge Trail, and the street number 17. We didn't know what zoning that was until it was connected, but we connected ID to parcel ID, and we can see right here that the zoning is RIB. Let's look at another one, this one on St. Arnaud. Again, it's saying it's R1B. Because we did this join, we were able to see that data. I'm just going to right click and look at the properties as well. And you can see that the zoning ID, parcel ID, and zoning are available. Now the one thing you'll notice that all the zoning pipe values, those are the ones that are coming from the other database that are joined, are not editable. They're read-only. When you join a table, the secondary table is not editable. It's just a read-only tool. The reason you join is so that you could label or you want to do thematic map using those fields. But for the most part, you're unable to edit that data. Now, if you want to join to another table, you can create a secondary join and go in here and manage joins. And you'll see the one that exists. You can either edit this one or create another one to a whole other database. So you could have one parcel layer joined to 3 or 4 different databases at your organization. If you need to edit it for any reason, you can click the edit. It'll bring up this dialog box again. So maybe you want the one-to-many show up or anything like that. So you can modify this primary table. It says the primary table is editable, but the secondary table is not. So let's close that. And there's no way in here to change that at this moment. So let's hit OK. And we've completely joined our data. Let's bring up the table again and show you again that there's some data that has a zoning. And if you look, most of these match. There's almost none that didn't match up with our current parcels. So that's a win. So we've got all the data showing inside our current drawing. So once your GIS is connected to another data source with joins, you can label, theme, or even filter your data using that additional data from the join features. Creating buffers around selected GIS features are useful for proximity analysis. For example, you could buffer a river segment by 50 feet and use that buffer to choose the trees that are protected by a riparian zone. Or in our case, we're going to buffer a particular parcel just so we can get a notification of all the parcels that are nearby. So in the Guelph DWG found under Chapter 10, 1002, let's drag and drop the parcels into it. We're going to zoom in to the subdivision in the south zone here. Now you can pick any one of these parcels, but I'm going to pick this one here on the corner. I'll zoom in. And what I'm trying to do is get out the data that I need. So if we look at the properties of this one parcel, I basically want a list of all the street names and street numbers that fall within 50 meters of that particular parcel. So I'll pick on that parcel first, pick the Analyze tab, and choose Feature Buffer. Now it shows already that one of the features are selected, one feature selected. Now you can manually go and pick another one at this point, but I'm just going to leave it for now. Distance will be 50 and make sure the units are meters. So I'm going to do a 50 meter buffer around it, and I'm going to call the layer buffer 50 meters. I'll just store it to the default. The buffer 50 meter will be right there. And then we have a merge results. No merging means every single buffer will be its own polygon. Merge all buffers means it's one big blob. It'll be every single buffer made. So every single buffer will be continued on multi-polygon. Or merge overlapping buffers. That means only those buffers that touch will be merged together. Otherwise, they'll be separate into separate entities inside the SDF. So this will actually create a brand new SDF that all that's in it are buffers. That's all that's in there, buffers. And it'll add that as a layer dynamically. So let's try this. A 50 meter buffer around that object. Let's go. There it is. So let's filter all the parcels that touch it, including itself. So to do that, we're going to do a secondary filter. So we go query to filter data. We're going to say locate on map that touches any part of that polygon. Let's choose select, pick on the buffer, and click OK. There's all the parcels that fall within there. Let's look at them in the table. There's only 8 of them. Basically, I want street name and street number exported so I can make a mail merge with Word or something like that. So how do we do that? First of all, we have to highlight them all. So I'll use my Shift key, highlight all 8, and they're highlighted on the map. I'll go to Options, Export, and I'll just put on my desktop. I'll just say Buffer 50. There we go. It's a CSV file. I'll hit Save. Now, if I look at that CSV file, I'll go to my desktop. You'll see buffer 50. I'll just edit with Notepad. And sure enough, there's each one of the parcels. We've got Serena Lane, 23, 19, and so on. We could use this for a mail merge and a notification system to let all those people know that there's going to be a zoning variance of that one particular address. So we've got a full circle of buffering, analysis, and using that buffer to do a mail merge. That's pretty powerful. So by combining a GIS buffer with a GIS vector data filter, this enables you to find all the features within a particular buffer zone. And you've also learned that all the buffers are permanently stored as a single SDF file. Superimposing 2 GIS vector layers to generate a combined graphics and attribute layer is called an overlay analysis. Let's overlay zoning with buildings so that the resulting layer will be the buildings with all the zoning information attached. So in the DWG found under 1003, let's drag and drop the zoning and buildings SDF to our current session. I'm going to make the buildings a slightly different color so we can tell that they are buildings on the map. Maybe I'll make them a cyan color or green. There's a green. There we are. So now we can see all the buildings are that green color. And what we're trying to do is take these buildings that have no data really and connect them to these zoning polygons that give you, like, that's a CBD, for example, and tag every building with a zoning designation. To do that, we need to go into the Analyze, and we'll do a feature overlay. The type of overlay we're going to be doing is the source being zoning with the overlay buildings. We're going to use intersect. There's lots of others. There's union that basically combines the both. We can erase that trims it. We can do identify, which actually maintains all the pieces. We can do a clip and paste and even a symmetric difference where you end up with holes inside your data. But in this case, we're going to do an intersect where the zoning polygons is the first item, the buildings is the second, and our result set is the identical shape. However, the buildings may be split where the zoning designations cross a building. So that building may be cut in half if half the building is in one zoning designation and another half in the other. But that's okay. So we're going to do that. That's how we're going to manage this. Let's go next. So the final result will be zoning building intersect on the desktop. I want the layer to be called zoning building intersect, just like that. Let's suggest the settings, and it does. And what happens is it basically checks for slivers. And slivers are those thin areas where two different polygons don't totally match up and they may be off by a little bit. So you end up with these tiny little polygons that don't mean much. And this suggested that the minimum and maximum size of a sliver is 0.1 meters to about a meter. It'll trim that. Now you could leave them in by checking don't remove slivers, but I like to remove them because they end up dirtying up your data quite a bit. And the tolerance is going to be about 0.01, which is quite small because that's about a centimeter. So that's pretty good. I might even make that a little bit bigger. Let's say 0.1. There we go. And output properties. Now we're going to output everything, and let's just hit finish and let this process. It may take a good 5 minutes to process because it's quite a complex query. So let's let that run. Once a new layer appears, you can turn off the other two, buildings and zoning. And we'll zoom in to the resulting zoning building intersect layer. If you pick on any of these features, you now have the zoning designation. Perhaps not that one. Let's go downtown in the CBD where I know there's CBD connection. Let's pick on this big building here. And sure enough, that's CBD right there. And right there. So you can see we now have buildings that are been cropped by the zoning designation. All those are CBD ones. And if I pan as I go over here, you can see that this building has R.3A, and part of the building may not have any zoning designation because it's been cropped right there. And that one does. Some do and some don't. But they all represent the zoning designations that were in the background. So if I turn on zoning, you can see that the overlay determines on what was behind. So if this zoning designation here said R1B, then the building inside of it should be R1B. But they may or may not have it depending on whether they intersect or not. So that's the resulting set. So you can see that where the zoning hits. So for example there, that's R3A-24. So you have all the various different types of zoning in the overlay analysis. So the intersection of two polygon layers always result in a layer of only those features that touch each other. We saw that we created a building layer with zoning data that can now be thematically color-coded based on the buildings and the zoning designation. Using calculated properties, you can calculate a new property for any feature based on its attributes or any joined data for that feature layer, including the geometry. You can use the resulting property to filter or select that data. Let's do that with the Buildings SDF under Chapter 10, 1004. Let's drag that into the Guelph DWG. Now the Buildings layer is very simple. It doesn't have much data assigned at all. So if you pick on one of the buildings and look at the properties, you'll see it's only got a feet ID or an ID. That's all it has. But we can add an additional property, such as area. So let's do that now. Let's right-click on the buildings and create a calculation. So we pick on create a calculation. And we're going to say area square meters. So we're going to use a geometric area 2 dimensions. So that's a function. I'll delete that to show you that again. So geometric area and 2D. If this was a linear feature, you could use length. But in this case, we use area 2D. And then the geometry property should be in the list here. Geometry. There it is. That's the name of the column. So we'll end up with area 2D geometry. Let's do that. Let's hit OK. Now if I look at the table, we've got a dynamic area in square meters. So any feature that has an area, so I think these are some null, yeah, they didn't get drawn in there. But we have some features that have full area. Scroll up and have a look at them, like this one here. So that you can see how big that's got 57,000 square meters. That's a big building. Okay. And the reason it's in square meters is because we're in a meters coordinate system, and that's the original data. So I want to basically have square feet. So let's go back into buildings, and we'll go into manage calculations. and we'll hit New Calculation. And let's call this area square feet. Okay, again, we're going to use geometric area. We're going to choose geometry, but we're going to have to multiply this to get from square meter to square feet. I think I have to multiply it by 10.764. So 10.764. And that should give me the area in square feet from the square meter. So let's hit OK. So we have area square meters and area square feet. So we've got two calculations. Let's bring up the table again. And sure enough, we've got area square meters and area square feet. Wasn't that interesting? Okay, let's do one more thing. So let's go back into our calculations. And I want to round both of these to the nearest decimal. So in the square meters, let's go into that one. And I'm going to highlight the whole thing. And I do have a math function. Let's see here. And I think we have a round. There it is, round. Number of decimals, I'll say 1. So you can see round, everything in brackets, and then the area. So we've nested it. So let's validate, make sure I've got everything right. Yeah, round to 1 decimal. And I'm going to do the same with the square feet as well. So I'll highlight everything, and I'll go to math function, round. You can see there's lots of math functions, 10 and arc10 and so on. But what I'm going to do is do round again, and again 1 decimal. And just in case, I'll hit validate. Oh yeah, it looks good. All right, let's hit OK. I'll look at the table. And sure enough, we've got the area in square meters and the area in square feet. And you can see them all. And we could even color code or export this at any time. If I wanted to give someone this permanently, I can always right click on buildings and save the layer as SDF. But in this case, I've got this. It's in my DWG. If I save my DWG right now, the square meters and square feet are stored inside the drawing. Not the SDF though. The SDF is still unchanged. This is a calculation just within this DWG that we're working on right now. I have square meters and square feet dynamically generated. So I pick on that one particular building. You can see it's got 405 square meters or 4,362 square feet. That's a pretty big building. There you are. So you've now learned to take an attribute, the geometry, and calculate the area and convert it to imperial. That was the 10.7 calculation we just did. Now this area is now available on the layer for anyone to use. So if you open this DWG, you always have that calculation. If the geometry changes, I grab a grip and move the size of the building, the calculated properties will automatically update. Splitting GIS vector data can mean losing attribute data. With AutoCAD Map 3D toolset, the split tool automatically copies the attribute data to both new features after the split. Let's split a large parcel in half, keeping the attribute data for the parcel in both halves of the split. So in your Guelph DWG found in exercise files, chapter 11, 1101, let's drag and drop the parcel split SDF into it. You'll see it's set between 2 points, above and beneath the parcel. There's only one parcel in this SDF, and that's the one we're going to split. But before we split it, let's look at some of the rules. Let's pick on parcels in the display manager and click table. In here, we can go to options, split and merge rules. The reason the split and merge rules are here in the data table is because it's the data that we're looking into, the attribute data. That's what the rules apply to. So let's pick on that. So the first item in the split and merge rules is the feature ID. Now you have no control of the rule because that's an auto number. Now the ID is a numeric int32. So the split rule gives you all sorts of options. You can copy it, which is the default, create a calculation, divide it, leave it blank, or proportional to the area. We're just going to leave it to copy. For street name, we have less choices. We have copy, we have empty, or do an expression. But remember, street name, because it's a string, you have less ability to do calculations. For street number, it's a string as well, so you're limited to what you can do. The geometry we have no control over. That's controlled by the splitting feature itself or the geometry itself. Okay, let's leave all three as copy, 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 and click OK. We'll close the data table and try splitting. So let's pick on feature edit, That's the ribbon up at the top, feature edit. And we're going to do a feature split. So we're going to select the feature that we're splitting, that one polygon. It's going to check out, say close. And we're going to select it. That's good. And press enter. We'll say new. It's not going to be a multi-part. It's going to be a new object. Multi-part meaning it's two pieces of the same polygon. No, we're going to split it in half. And we're going to create a new ID. And we'll draw. And we're going to go to the center of the first point and to the end point. And then go click and press enter. And what happens is that line I just drew will split the polygon into two pieces. So on the one side, the first item at the top, that's going to be 3 Trent Lane. So let's fix that right now. And the second one is 1. So what we've done is we've copied the ID, we've copied the street name, and we copied the street number, but I manually changed the street number. Because even with a calculation, say I even wanted to add 2 to 1, which one would it be, the upper one or the lower one? So there's a lot of logic there. So it was easier for me to just go in and change the street number. All I have to do is right click and check in the layer, and this is now a permanent change. So after splitting the parcel, you can edit the attributes in either new parcel or leave the defaults, which by default is identical. Combining two GIS vector features together requires a process to adopt the attributes of the primary feature. For example, if you merge addresses together, 10 and 12 Main Street, you can choose to take all the attributes from 10 Main Street as the primary data source. That's exactly what we're going to do here. So in exercise files, chapter 11, 1102, in the Guelph DWG, let's drag and drop the parcel merge SDF. You'll see it's 2 separate polygons. Let's open up the table. And you'll see one is 1 Trent Lane and the other is 3 Trent Lane. We're going to merge them together and make them both 1 Trent Lane. But to do that, we need to set some rules. So inside of the data pane here, let's go options, set split and merge rules. So let's look at the feature ID. There's no merge rule for feature ID because it's auto number. ID, which is an integer, says merge sum or set an average, calculation, count, all sorts of things. But what we're going to choose is first selected. So instead of worrying about what ID to use, we're going to say whatever the first polygon we choose to merge, that will be the first one. So the ID will be the very first item. Same with the street name. We'll say first selected, as well as the street first selected. Now again, there's less rules for a string such as street name or street no. You can concatenate, you can leave it empty, you can build an expression, first or last selected. We're going to choose first. Whereas the ID, because it's a numeric, we can do all sorts of things like get the maximum, the median, standard deviation, the sum of all of them. So having numeric gives you a lot more tools for how you calculate what the merged value is. But we're just going to say first selected. Geometry, we have no control because that's defined by the object itself. So now we know the ID, first selected, street name first selected, and street no first selected. Perfect. Let's click OK. Our rules are now set. So let's go into the feature edit. And now we're going to choose the merge feature. Let's pick on that. Select features to merge. The first one we'll select is the bottom. We'll check it out. And we'll merge it with the second item. And then we'll press enter. Select the feature ID to use. We'll select this one, the bottom one. And now we can see that the new feature is 1 Trent Lane with the 1 ID. So it's only one feature left. It's been merged together. So we can see 1 Trent Lane is now that complete. I'll check it in and the pencil mark will go away. But one thing you should notice, because we've made a third object based on the 2 pieces, the feature ID is now number 3. So what it's done, it's got 1 and 2 and combined to become 3. But the feature ID is an auto number, so we're not too worried about that. The most important thing is the ID, the 15668 here, and it's now back to 1 Trent Lane. So by combining the 2 vector data together within a GIS context, you can have a devastating consequences in terms of all these attributes. Now the merge tool in AutoCAD Map 3D helps maintain the attributes while still keeping the spatial integrity of both features when we merge them together. Coordinate systems should be assigned to all DWG files, although non-geographic files, for example, data inserted at 00, don't really require a coordinate system. Most data used within AutoCAD Map 3D does require one. There are approximately 4,000 coordinate systems to choose from, and you can even create your own. Let's assign a coordinate system to the hydrology DWG under Chapter 12, 1201. So open that up. And here's the hydrology drawing. Now, if you're not sure what coordinate system it's in, normally when I receive one, I ask around. In fact, I rarely accept any drawings from people if I don't have the metadata or information about the coordinate system. It's really critical. Now, I could guess, and there's a technique to guessing. What I can do is I can go to this menu option down here, the customization, line, at the very bottom. You see the stack? And I scroll all the way up to the top and I turn on coordinates. Now the coordinates are on. I can move my cursor around and you'll see at the very bottom of the screen, it says -80, 43. And I can kind of guess that's latitude, longitude. I can kind of guess that because those are sort of the coordinates and I know this area. So how do I assign the coordinate system? I happen to know it's in lat long. So let's go to Map Setup ribbon and choose Assign. And this is where we can find all the coordinate system. So I can search for a particular word. I can type latitude. And it'll filter all the coordinate systems with the word latitude in it. Now the one I know it's in is in lat long 84. There it is. LL84 is the code inside of AutoCAD Map, also known as WGS 84, or globally the EPSG code 4326. And that's a very common one for lat long 84, 4326. Let's assign that. Click Assign. And now you should see in the bottom of your screen that the coordinate system is assigned LL84 right at the bottom, so that you can see that at a glance. So that's great. We've now assigned the hydrology lat long 84. Okay, so let's go to the other drawing, and that is the streets drawing. So open up streets. Now this one, I'm moving my cursor around and some of the coordinates are quite large. Now this one would be very difficult to guess, but I know it's the spherical Mercator, the web Mercator one that Google uses. So again, pick on Map Setup, pick Assign, and we could say SPH spherical. There it is, WGS spherical. Or I know the code 3857. And there it is. See, the EPSG code is right there, 3857. That's the one that Google and Bing and all the web-based tools use. And that one is inside of AutoCAD Map. Its code is WGS84 Student Mercator. But everyone else might know it as 3857 if you're using other tools. So there it is. So we'll assign that. And now if you look at the bottom of your screen, it says WGS84 Student Mercator. Now there's other ways to assign a coordinate system. We could actually use that drop down box and go to Library at the bottom and choose your coordinate system. Another technique would be to go into Map Explorer, right click on current drawing and choose coordinate system and then hit select coordinate system. It takes you to the same coordinate system library. So there's many different ways to getting to the same place. But now you could see that we've got WGS 84 Student Mercator for streets and lat long 84 for hydrology. Now assigning coordinate system doesn't reproject anything when you assign it to a DWG. Not at first. Really all it is a note or metadata on the drawing to let AutoCAD know what this particular drawing is in. It's basically a post-it note. So it's just a flag. So assigning coordinate system to your DWG does not reproject the data. The coordinate system is just a flag to allow AutoCAD Map 3D to know what the coordinate system is used for future use, especially when exporting data or attaching to a project. To reproject AutoCAD data, the DWG must have a coordinate system assigned. You attach DWG to a new drawing with the destination coordinate system and query the source drawing to get the data in the correct coordinate system. Let's look how all that works. First of all, I have a project drawing called Guelph.dwg. Its coordinate system is UTM 8317, so it's in zone 17. Let's attach two drawings that may be in a different coordinate system. So under Map Explorer, right-click, choose Attach. We're going to make sure we use the exercise files alias, Chapter 12, 1202. We're going to choose Hydrology and Streets and click OK. Let's just do a quick view on those just to see if they're in the right location and click OK. And there's a quick view. It's actually drawing all the streets and all the hydrology in the correct location. Now, these are in UTM, but the source drawings might be in something else. Let's just check that. So if we right click and go to Define Modify Drawing Set, sure enough, there's the two attached ones. But there's an extra button here in the drawing set called Drawing Settings. This gives us a little more information about the drawings that we have attached right now. If I pick on that, it'll show, yes, the hydrology is in LL84, and the streets are in Pseudo Mercator or 3857. And there's the save back extents. This is the extents of that particular drawing. And this is the extents of that particular drawing. But you'll notice the save back extents are actually in UTM of our current drawing. So it knows that in this current drawing, within that boundary, that if you were to edit any data here, it will be saved back into that drawing. Okay, let's just close this for now. And click OK. So this is how you reproject data from another DWG. Now remember, this isn't GIS data. This isn't FDO data. These are polylines and polygons and blocks and P-lines, basically AutoCAD objects. So the only way to reproject an AutoCAD object is to make sure that the DWG is assigned like this one and the other two that are attached, and do a query and pull it in. Now what if I wanted to permanently fix, say, my streets drawing? You saw before streets. Let's look at that again. Modify Drawing Settings. Streets are in Pseudo Mercator. What if I wanted the streets to be permanently UTM 17? Well, that's a fairly simple process. So let's do this. Let's start a brand new drawing and assign the coordinate system of the brand new drawing to UTM. So go to None Library at the bottom there, and we'll type UTM 83-17. There it is, the first one. And then we'll attach the streets. So exercise files, chapter 12, lesson 2, streets. There we are. And let's just do a quick view and zoom extents. Make sure we zoom all. Try that again. Quick view. There they are. Okay, good view. So there we are. If we look at the defined drawing set and we look at the drawing settings, again, it's in WGS Pseudo Mercator. But what we want is to make sure that this is in UTM. So how would we do that? Well, the fastest way is by using a query. So what we're going to do is we're going to go query. We're going to say location all. So basically bring in everything. So I'm using a location query in my query library. I'm going to put it in draw mode. So it's going to pull every single thing out of this attached streets into draw mode. I'll hit execute. So now if I zoom in and pick on something, that street right there, look at the properties. You can see, yeah, it's a P line. It's on the streets layer. It's got visualization. It even has object data. Now, how do I make this permanent? Well, what I do, and this is the best part, you detach the source drawing. So we're going to break my project. I'm going to say, let's not worry about the original, detach. And it says the 3,144 objects queried will now be treated as newly created objects. Good. That's exactly what I want. I want these to be brand new objects. And look at my coordinate system. It's UTM 83-17. Now, if I save this drawing right now, I'll just put it on my desktop. I'm going to call it streets underscore UTM. So now I've completely reprojected the source data, the DWG, into a brand new drawing. So it's a copy of the original, but this one is in UTM. Everything's correct. So if I put on the base map in the background, just to show you, so if I go map on, I'll use map road. You can see everything's in the correct location. The streets are where they should be. Even though I'm in UTM, There's no attached drawing, so this is live inside this one drawing. These objects live in the street UTM DWG, and they have been reprojected. So that's how you do it. You always attach the one that's in the projection you don't like anymore, query it into a DWG that you do like, detach it, and save it as a new drawing. And that's the fastest technique to permanently change your data into the new coordinate set. So reprojecting your DWG data is not dynamic, and it requires that you query in the source drawing in order to reproject it into the new coordinate system. There's no other way within the AutoCAD map to move DWG-based data. Now, GIS data is completely different, and we'll talk about that in another lesson. GIS data is usually already flagged with a coordinate system. If your DWG also has a coordinate system assigned, your GIS data will dynamically reproject. Now, unlike DWG data, when you change the coordinate system inside your DWG, all the attached GIS data will automatically reproject. Let's try that now. So let's grab the curbs, the hydrology, and streets SDF under Chapter 12, 1203, and put it into the Guelph DWG. So you'll see that hydrology, curbs, and streets are all attached automatically. They're reprojected in pseudo Mercator. The original coordinate system, we can tell on hydrology, curbs, and streets. If we go to data, connect to data, we can see if we pick on curbs that that's in pseudo Mercator. Hydrology is in lat long 84, and streets are also in pseudo Mercator. Our current drawing is in pseudo Mercator. And if I turn off hydrology, curbs, and streets, you'll see the city outline in the background. If I pick on it, you can see that's a P line. That is AutoCAD objects. So let's try something. If I change the current coordinate system to say lat long 84, let's pick on library, and change the current coordinate system to LL84 and hit where we are, there it is, LL84, pick assign. Now what happens is all the GIS data that's attached will automatically reproject and put it in the new location. Now if I zoom out, we'll probably see the city limits way over here. It's in the wrong location. Because the very act of doing what I just did with my data by putting in lat long 84, let's just zoom to curbs and zoom to hydrology. There we are. We've basically told my DWG that it's currently in lat long 84. So all the GIS data that's along for the ride will happily reproject and put it in the right location. And I can really show this by going to home and turning on the aerial. Now it may not work with that LL84. Let's try a different coordinate system. Let's pick UTM because Bing doesn't like lat long. So let's say UTM 83-17, which is where all this data comes from. Let's hit assign. And sure enough, this gets reprojected nicely. And if I turn on the map to map road, we should get the map this time because it's not lat long. Everything is reprojected in the right location. I see it's in the right city. Everything looks good. The hydrology, the curbs, and so on. There's the streets in the background. They're all in the right location. But you know what's not in the right location? That city outline, that DWG. And the reason it's not coming along for the ride is because it's in the web Mercator, the pseudo Mercator. And by changing the coordinate system of my DWG, I've given this DWG the wrong coordinate system. The right coordinate system is the WGS, pseudo Mercator, right there. Let's fix this current DWG. And guess what? It's in the background now. Let's look. There's my outline. Because this coordinate system should always be set to whatever your DWG objects are, not your GIS objects. Your GIS objects will always come along for the ride, but the DWG objects don't. So your hydrology, your curbs, your streets will just happily reproject to whatever coordinate system you have, but your DWG in the background won't. So always set your current coordinate system of your DWG to what the CAD objects dictate, not to what the GIS objects dictate. If you want them in a different projection, what you should do is then attach that and query it in as a source drawing if you want it to be reprojected, because otherwise the DWGs won't. But of course, the GIS data always will. So you've learned that changing the coordinate system of your DWG will dynamically reproject your attached GIS data, just not your current GIS data. In order to create a map book, we need a number of files ready to go. We need the main map, the DWG, the overview map, DWG. We need a DWT, that is the AutoCAD template that has all the default plotter layouts, the viewports, the overview map, and the current grid number. Let's put all those together first. So the first thing we're going to do is we're going to open up the Guelph DWG under Exercise Files, Chapter 13, 1301, and we're going to add the curbs, the hydrology, the parcels, and the street. And this is what we're going to be plotting. So we might as well put all this data into our current map. And we'll make sure everything's sorted. We'll put the streets above hydrology. And let's author this really quickly. So what I'm going to do is I'm going to make the parcels a lighter color, maybe semi-transparent. So I'll take them in here and I'll take the fill and I'll make it a lighter sort of a beige color. Maybe make the transparent 50. That'll look nicer. The next thing I want to do is pick on the curbs, and I just want them a light gray color. So we'll change the color to a gray. There we go. And we'll take the hydrology and make it blue, a light blue. And finally, the streets, we'll make them a black color. There we go. So this is our Guelph map. There it is. And not only that, we've got this nice Guelph map. We'll save it, but also we're going to save as, and we're going to put it in the same location, 1301, but we're going to call it Guelph Overview, because that'll be the overview map, the thumbnail map. And we may want to take our parcels and have them turn off at that scale. So if this is the overview map, we may not want the parcels on. We may just want the hydrology, the streets, and maybe they turn the curbs off as well. So we just have the streets and hydrology in the city outline, which is part of this DWG, as the Guelph overview, and I'll save that. So then if we look at our different files now in our directory, we have the Guelph DWG, that's our main map. We have the Guelph overview. This will be the overview map, the inset map. And then finally, we have this template. This template is a DWT. It's called a mapbook template. It'll be 11 by 17 classic. That's the layout we're going to be using. Let's open that up now. So once it opens, we're just going to zoom extents just to have a look at it. There we go. And this is just the print layout or paper space. The model space absolutely has nothing in it. This drawing has nothing in it. The only thing that this drawing or this template has is this layout. Now this layout is a little bit complex because it has some really neat things. It has two viewports. It has this main viewport right here. If we look at the properties of that, you can see that's a viewport. There it is. And we have a secondary viewport over here where our key map is going. So the Guelph DWG will be in this main viewport, and the Guelph Overview DWG will be in this key map area. The legend will be dynamically generated from the current map. We can put in the organization name we want here. The scale can be automatically populated. See this block here? We've got all these attributes in these blocks. We have got organization name. You can populate that. We've got the file name, which will be dynamic. We have plot date. We can just manually type that in. We have the drawing scale, which will be automatically populated, as well as the sheet number. One other really neat thing about the blocks in here is these side blocks and bottom blocks. Now these are great because what these blocks will do, they're next page blocks. They're adjacent arrows. They have a tag called next page, and that will be populated with those grid cells in the map that are to the top, to the left, to the right, and to the bottom of the current page. And plus we have a north arrow. So this block layout is very powerful. We have a main viewport with the Guelph DWG will go in. We have the key map, which is the Guelph overview DWG, and then this DWT will drive how this whole thing looks. So if we go back to our drawings, you can see we've got a Guelph DWG, that'll be in the main viewport. The Guelph overview will be in the key map. We'll use this DWT to drive everything. And then the other support files are just the parcels, streets, and so on, which are part of the Guelph DWG and the Guelph overview. One thing we have to look at, though, is the NCB printout. So if you look at this print layout, all we have to do is right-click on it and go into the Page Setup Manager. And you'll see this NCB list there. We'll pick on Modify. And what this is a DWF e-plot. So this will plot out to a DWF format. Now we could switch this to PDF or anything else, but I'm just going to leave it as a DWF 6. So it's a DWF is the drawing web format supported by Autodesk. We could choose a PDF as well, and that works great. We have a paper size NCB, so it's going to be 11 by 17, and we'll plot the layout, and it scales 1:1, and that's the layout for this, and it's going to plot landscape. So we've got this all set up, so we'll hit OK, close, and if you want to modify this in any way you can, and then make sure you save it as a DWT file. Because I opened it directly, it considers it a DWG, so I'll have to save as a DWT. So we're all set up. We've got all the files we need. So once we have all these supporting files and they're all ready, we can generate the map book. We can produce the books with all these support files. That's critical. So we have the main map, the overview map, all the support files and connections, as well as the DWT that drives everything. Once we have all that, we can generate our map book. Map books are used to plot a series of maps that dice your data into sections with a title block. The title block usually has a predefined viewport, such as an overview map viewport and a main map viewport. It may also have legends. Now let's use a map in a pre-created drawing template with a title block and viewports to create the map book set. So first, inside of exercise files, chapter 13, 13.2, open up the Guelph DWG. This will be our main plotting map. We're also going to have the Guelph overview for a key map or inset map. And we're also going to be using the map book template. This contains all the template and layouts for plotting. The curbs, hydrology, parcels, and street SDFs are attached to both Guelph DWG and the Guelph overview DWG, just for making the maps themselves. Okay, so inside the Guelph DWG file, we're going to pick on the map book tab inside the task pane, and we're going to click new map book. So we're going to start map books from scratch. The map book name, we'll call it Guelph Map Book. For the sheet template, pick on settings, and we're going to browse to that DWT file that's in 13.2. There it is, map book template, 11 by 17. Inside it, we're going to choose a layout. There's only one print layout. It's NCB. It's already been made. From within the layout options, you can choose a title block. The title block we're going to use is called title block. For the adjacent sheet links, those are the 4 links around the main map where you could have a hyperlink linking to the other sheets. That's called the adjacent arrow 4. That's the block that has the hyperlinks in it. And each tile will be a 1:500 scale. Okay, let's look at the tiling scheme. We could choose by number, but what we're going to do instead is pick by area and window and area. We'll leave the layer 0. We're going to select area to tile. And we're going to circumscribe the parcels. So we're going to pick right up in the corner here and draw a box and just sort of get the bottom part of the city. There we are. That looks pretty good. And we'll skip any empty tiles because we don't want blank maps. Okay, we'll go to the naming scheme now. We've picked the tile scheme. We see that the first corner and the opposite corner are set in there. We've got a 5% overlap between each tile, and we're skipping any empty ones. So under naming scheme, let's go to columns and rows. We're going to have A, B, C, D across the top, incrementing by 1, so it's A, B, C. But then in the columns, they're going to go 1, 2, 3, 4. But right now it starts with 5, so we're going to set to 1. and it's going to increment by 1. So it'll be 1, 2, 3, 4. So we'll end up with A1, B1, A2, B2, and so on. And we'll keep that all set up. And we'll skip names for skip tiles so the numbering doesn't get offset. For the key map, we're going to pick external reference and browse to our Guelph overview DWG. There it is. That's already been pre-made. So far we've already chosen our model space, Guelph Mapbook. Our settings are going to use that Mapbook template, DWT. We've picked the overview map. We're not going to choose a legend, so let's leave that to none. And sheet set, we'll create a brand new sheet set. It'll just dump the DST file into the same directory as all our exercise files. Before we go forward, I'm going to click Preview Tiles. That'll show you the grid of where the tiles are. So you'll have 4 across A, B, C, D, and 1, 2, 3, 4. So this whole tile set will be 4 by 4. That looks good. Okay, so let's click Generate. Oh, it says there's a map book already exists. Let's make it unique. We'll call it Map Books, plural. And there's our grid set. You can see there's a blank tile in this one corner, but we've got Guelph Map Books. A has 1, 2, 3, 4. B, so if we look at C1, for example, I could right click on it and zoom to the tile. There it is there. That's C1. Or if I right click, I can go zoom to the layout. So what happens is within our map, we've created a whole series of layouts at the bottom. We have Guelph Mapbooks -C1. So there's a whole series down here of mapbooks. See, there's a whole bunch from A1 all the way to D4. And we can zoom to them or pick it if we wish to. Or if that was D4 right there, or that's C2 right there, if I want D2, I can right click and say zoom layout. It'll jump to that layout, so I don't have to pick it. Or I could right click and see 3 and go zoom layout, and it'll zoom. The great thing about this is that I could pick each individual layout and plot it individually. So I could right click and say publish to DWF. Now the DWF, or the drawing web format, is an Autodesk format, and you'll need Autodesk Design Review in order to view it, or you can go to viewer.autodesk.com and publish this and push it up online. So viewer.autodesk.com or the Autodesk Design Review. There's 2 ways of looking at DWF files. Or publish the plotter, and if I do that, it'll just publish the PDF. Yeah, I'll say yes, and it'll publish that as a PDF, and the plot manager will let me know when that's finished. So it's publishing in the background. You can see that the little printer icon's running. It'll let me know when it's done. Alternatively, I could right click on the entire map books and I could publish the entire thing to DWF or all the map sheets to the plotter. Well, right now, this template's set up to a PDF. So if I were to publish this, it would just pump out all these 9 or 10 PDFs. Actually, I think there's 11 because it's 4 by 4, but one's missing. So it's actually 11. So if I publish the plotter right now, it'll be 11 PDFs, all printed. And then you could print each one individually to a real plotter if you wish. So that's really powerful. Now, if the data updates or anything like that, you could rebuild the entire map book or create a different map book. Now, you can make as many map books as you wish because maybe your title block is different for different purposes, or you have a completely different map or organization you're printing for. And there you go. It says it's plotted. So not only have you created a map book, you've also published it out as a DWF, the drawing web format. Now, you could view this using the Autodesk Design Review, or again, you use viewer.autodesk.com.